Apache Airflow 3.0 is officially here, rebuilt, faster, and completely modern. If you are still building production pipelines the old way, you are falling behind. Welcome to the most detailed Apache Airflow 3.0 tutorial. In this 4 plus hours of tutorial, we will not be only looking at the definitions, we will be diving straight into the depth of the concepts. We will be exploring the advanced and the brand new architecture updates, and we will also working with the advanced operators and the next gen scheduling features. And you can see on your screen how detailed this is. We are literally covering orchestration, airflow, all the core components. Then I am even covering the Apache Airflow 3.0 latest architecture, which even if you go to documentation and try to understand, it will be very tough. And I'm not stopping only on the 3.0 architecture. I will also be talking in detailed about the scalable airflow architecture, which is nowadays the market standard. Then we will be installing and we will be working with DAGs, parallel task, XCOMs, schedule, incremental loading, assets, and then we will be implementing a end-to-end project, and we will be using a API. Then we will be loading the data into our Snowflake. Then from Snowflake, we will be creating a CSV file and loading into the S3. A complete end-to-end project we will be creating, and also we will be discussing about the tag inheritance. Whether you are looking to upgrade your existing stack or breaking into the allied data engineering roles, this is the only tutorial you need. Drop a like, hit subscribe to join the Data to Dollars community, and let's get started with the orchestrations. Now let's start with the very first topic, which is orchestration. Before directly jumping into what is orchestration, let's understand the problem statement first. Let's say you have an Excel file and you had scheduled the Excel file, and data is getting loaded directly into the databases. Everything is looking good, but let's say there is another file came tomorrow, and this is also getting loaded into the database, and you had scheduled that as well. And then another file came which is also dependent on this file A, and this is also getting loaded into the database. Then one more file came, and this is dependent on these two files. And once these two files had completed the schedule, it will be loading into the database. But now the problem is, let's say you had scheduled that for every 5 minutes. This is scheduled at 4 p.m. and then both of these files are scheduled at 4:05, and then the next file is scheduled as 4:10. Let's say due to XYZ reason, this file ran till 4:10. Then what will happen? This will be failing and this will also be failing because these files are dependent on this file, and we had individually scheduled them just on the guess basis. So this will eventually leads to a failure, right? The whole process will fail, correct? But now, instead of scheduling after every 5 minutes, you are scheduling it in a way that once the first file run, then it will run the second files, and then it will run the final file, and once the final file ran, then it will load the data into my database. So in this way, you had eliminated this scheduler of after every 5 minutes. You have only one scheduler which runs at 4 p.m. and it is ensuring the atomicity because every file is running in an atomic way. This whole process is known as orchestration. So if I have to write, I will say orchestration is the automated process that controls the entire web of pipelines, or you can say steps. So this is what orchestration is. It is just a process which controls the entire steps required till the loading of data. From the orchestration term, there is a next term which is known as orchestrators. So orchestrators are nothing, just a service which allows you to develop the consistent patterns across all the steps. They come with some built-in protocols for handling all kind of pipeline crashes and all kind of failures and any kind of inconsistencies. And with orchestrators, processes can be set up to run in a chain, like you can see, either sequentially or concurrently, which reduces the bottleneck of maintaining the perfect order of execution. So one of the orchestrator is Apache Airflow. Airflow was launched in 2015 by Airbnb. Since its release, Airflow became the undisputed king of data engineering orchestration. It offers friendly monitoring, configurations, and even you can write your code using Python and you can create DAGs and tasks. So the fact here is that all the code dependencies, all the logs, all the triggers, and all the status are kept in one central location without you needing to build yourself a massive solution is known as Airflow. In Airflows, we have DAGs and tasks we just discussed, right? So what is DAG? Let me write it down here. DAG. So DAGs are simply a collection of tasks organized by their relationships and dependencies. That's it. So Jaswinder, then what is task? Task is simply a script performing a specific functionality. That's it. Now I hope you are very clear what is orchestration and how Airflow helps in orchestrating the thing, and what is DAG and what are tasks. Now let's read the official Airflow definition. Apache Airflow is an open source platform used by data engineers to programmatically author, schedule, and monitor the complex workflows or the data pipelines. It allows the developer to define the sequences of tasks. Now you know what are tasks in Python code as DAGs, and you also know what are DAGs. This is how we should be understanding the definitions, because this is how I learn the things. So now we know what is Apache Airflow. Let's also try to understand what Airflow is not. So first thing, Airflow is not a transformation framework. And I guess you are very clear. It is only and only used for orchestration purposes. And second thing is, it is not a ETL tool. Okay, it only is something which can extract and load the data, but it is not having any kind of transformation framework. So that's why it is not an ETL tool. And third thing is, it is not meant for streaming workloads. It is only meant for batch loading. Okay, so this is what Airflow is not. Make sense? Perfect. Let's now discuss about another core component of Airflow after DAG and task, which is known as metadata. So what is metadata? It's nothing just the any information about data, like this DAG run schedule, the task history, the failures, the success, right? Anything which is related to the information of the data. That is known as metadata DB. And this is the backbone for the Apache Airflow, because everything is stored inside the metadata, and Airflow uses metadata to operate totally within the instance. Without metadata, Airflow can't work at all. Now, next component we have is DAG file processor. In order to understand the DAG file processor, I will be using this image which I had copy pasted from the Google. If you see here, this is the image when some developer was creating the DAGs inside the VS Code. So you can see there is a folder called DAGs, right? And this folder we only create. Okay. Inside this folder, we write all the Python codes which represents the DAGs. So what happens is, this DAG file processor parses all the Python script. In this case, let's say the example DAG basic and example DAG advanced. It will parse both the Python scripts present inside this DAG folder, and it will convert them into the executable DAG objects. Executable DAG objects. So it will convert these Python scripts into executable DAG objects, and also it will serialize the executable DAG objects back into the metadata database. I hope this makes sense to you. Let me write the definition as well. DAG file processor is a critical engine component responsible for parsing Python scripts present inside the DAG folder. In this case, it will parse example tag advanced and example tag basics. And once it parses it, it will convert them into executable DAG objects. And once it had converted them into the DAG objects, it will serialize them into metadata database. This is how this DAG file processor works. So it parses my Python scripts, and once it parses the scripts, it will convert those scripts into executable DAG objects. And once that is also done, it serializes them into the metadata database. I hope this is clear. This is my DAG folder. These are my Python files. It converted my Python files into executable DAG objects. Then it will serialize them into my metadata database. This whole process is known as DAG file processor. Jaswinder, we have one question. You told that DAG processor will be parsing my Python and it will be converting them into the executable DAG objects, and then it will serialize them into the metadata database. But how DAG processor is able to communicate with the metadata database? How? That's a good question. For that, we have a concept called API server. So API server acts as a middleman between the DAG file processor and the metadata database. And it will store all the information and it will go back and forth. Okay, Jaswinder, can you give us one more example? Definitely yes. For that, I will just click on a new tab and I will say Airflow UI, and I will go to images, and yeah, this image is fine. So see this image, guys. So here we are having a couple of options like metadatabase, scheduler, trigger, DAG, processors, and then we have all the information of the queue and successful and the failure. So this is just the front end, right? How it is able to detect how many jobs are successful, how many are failed, how many task instances I am having, and what is the success state overall and everything. How? And even I am seeing the task history. This is because the API server is connected to this front end and eventually it is hitting back my metadata database to get all the information you are seeing on your screen. Now it makes sense? Perfect. Similarly, we have one more thing which is scheduler. Here you can clearly see this is mentioned. So scheduler is self-explanatory. It will be useful to schedule the jobs, right? Perfect. Now I had also written the definition of scheduler for you guys so that you can just understand the definition perspective as well. So I will just read it out for you guys. Scheduler is a persistent multi-threaded service that continuously monitors your DAGs and task states. Makes sense. It parses your workflow definitions using the DAG file processor and checks if the dependencies are met and triggers the task instances when it is the time to execute them. Now let's understand another two core components which are known as executor and second component is worker. What, Jaswinder? As per our Apache Spark knowledge, we know that executor is only the worker. I know, guys, in Apache Spark, executor is only the worker, but in Airflow, executor is different than the worker. Or you can say it's like your project manager, which gets the instruction from your scheduler. It will go to your scheduler and get the instructions, and then it will create the task for the workers. And the workers are the main layer of the executions. Okay, I will write it here as well. Main layer of execution. Cool. So it's like your project manager and worker is the worker here. Cool. So this is the difference between the executor and worker. Another core component of Airflow is queue. So I guess you are already aware about what is queue. It is nothing just first in, first out. So what happens here is it is still first in, first out, no doubt, because that's the behavior of a queue. But in the queue, we are having two kind of queues. First is known as execution queue and second is known as Redis queue. And this is again very specific for the Airflow. So what is execution queue and Redis queue? Let me explain you with an example. So let's say this is your queue and there are tasks. So now you tell me that who could have created these tasks? If your answer is that worker node had created this task, you are partially correct actually. So what happens is executor also create the task and it will define the task inside a queue. So when executor creates a queue, obviously it is creating a queue for the workers, right? So this queue is known as execution queue. Similar way, workers also create a queue. There might be ample amount of workers, right? So workers should also have a queue so that they can pick the task from their queue, and that queue is known as Redis queue. Jaswinder, why we need two kind of queues? So basically, by default, all the tasks go to the queue named default. Okay, so there is a queue which is named as default. Okay, all the tasks will go to that queue. Let me copy paste. Let me copy and create another one. I will point this one to here. Yes, what happens is by default, all the tasks go to a queue which is named as default. So this is useful for the resource management. This is not used for any physical pipeline executions. Okay, but the Redis queue is the physical pipeline. When the Airflow scheduler decides a task based on the FIFO principle, it writes the message into the Redis and then it will execute the task in the order of first in, first out. Make sense? So, this is why there are two queues. Executor queue is for the resource management and the worker queue is the main queue which runs the task. Jaswinder, why this is a Redis queue? Basically, Airflow does not actually know how to pass the messages across a network to the different worker machines. In the real scenario, you won't be having a single worker machine. You will be having ample amount of worker machines, and Airflow don't have any kind of stateful memory which will be knowing that how to pass the message. So in order to pass the message, it needs a message broker to do all these kind of heavy lifting. And this is where Redis come into picture. Okay. Now I hope you are very clear about the worker and executor relation, how the queues are getting created, and how the worker nodes pull the task from the Redis queue. Let's now also understand the last core component of Apache Airflow, which is triggerer. So triggerer is not the scheduler. Scheduler is very different than the triggerer. So what triggerer is? Triggerer is a deferrable operator. What happens is, let me give you the example what I mean by deferrable operator. But first I will write it here. Deferrable operator. So what I mean is, let me take one example. I will grab something. I will grab Snowflake, let's say. Okay. So now worker node have some task. So worker is having some task which will take a lot of time. Maybe 3 hours or 4 hours or 10 hours. I don't know. Instead of waiting for the task which is, let's say, on Snowflake, it will pass this task to the triggerer. So what it will say that, hey triggerer, please take this task from me, and once this task get completed, just inform me back. So in this way, let's say this task took 4 hours, that will be totally fine because worker had handed over the task to the triggerer and it had gone for the next task. So this is the helper for the worker. So that's why I had written that it's the deferrable operator. Because when workers will delegate the task to the triggerer will keep on pinging the Snowflake API, let's say after n seconds, and till the time Snowflake don't return the results back, it will keep on triggering. And once Snowflake sends the results back, whatever is requested, triggerer will immediately go to the worker node and worker node will say, hey, I am busy. So then what will triggerer do is, triggerer will go to the executor node and create a task in the executor node. Again, it will go for a queue and this queue will be executed as per its priority. So this is how triggerer works. Let me re-explain. So there is a worker node. It got a task to run some functionality on Snowflake. It hit the Snowflake, but it don't know how much time it will take. So what worker will do, it will assign this task to the triggerer, And triggerer will keep on pinging the Snowflake API continuously after a certain amount of time. And once Snowflake gives back the response to triggerer, it will try to go to worker node. But worker node will say, no, triggerer, I can't take this task right now because I am having the another task with me. So please go to the executor. Triggerer will go to the executor and it will assign this task in the execution queue. And now this task will be executed as per the priorities, which is FIFO. This is how triggerer works within the Apache Airflow instance. I hope this is very clear now. And similar way, let's say worker node got a task which is requesting the email confirmation. Then again, the worker node will assign the task to triggerer and triggerer will wait for the email confirmation. And once triggerer will get the email confirmation, it will eventually go to the executor queue and it will queue the task results. And then again, once the priority of that task will be reached, it will be executed by the workers. This is how the Apache Airflow core components work jointly to create a unified architecture, which we are gonna cover now. I hope this is very clear what is metadata database, how DAG file processor is linked with the metadata database using API server, how scheduler works in the Airflow, and what is the role of executor and worker, and how we are having two kind of queues, execution queues and redis queue, and the role of the triggerer. These all 6 7 components combinedly becomes the Airflow architecture, which we are gonna cover now. I hope this is very clear. If this is not clear, please do revisit this part. Let's now discuss about the most detailed Airflow 3.0 architecture, which is the latest architecture as per July 2026. Let's start with the Airflow UI. So let's assume this is our Airflow UI. So before any task can execute, Airflow needs to know what to run, right? For that, Airflow create a connection with DAGs and logs storage. So this is my DAGs and log storage. So it's nothing, just the DAG folder present in the Airflow. I will name this as DAGs and log storage. This is where I have all the DAGs in the Python which we had created, right? So now what will happen next is there will be a scheduler in the picture. And let's say this is my scheduler. This scheduler will go to this DAG and log storage, which is just my directory, and it will continuously keep on polling. So for polling, I will just do something like that. So it will keep on polling the DAG and log storage to read my Python workflow files present inside my DAG and log storage directory. I will write here, it is polling. So once it is able to see my Python workflow files, because it is continuously polling, it will parse my Python file to understand the structure of DAG. What it will do, it will parse the Python files. While parsing, it means that it will try to understand the DAG and its task and all the specific dependency. So this scheduler is also polling as well as parsing my Python file and trying to understand the DAG structure. So let's say it had parsed my DAG like this. All the tasks it had parsed. Once the scheduler parse the DAGs, it needs to save this structure somewhere, right? So now two things will come into picture. First is my database, which is Postgres database. Second thing is my API server. Let's say this is my internal API server. So it needs two things because Airflow architecture no longer allows direct change in the databases. Now every change in the Airflow 3.0 should be going through the internal API server only. So now scheduler will make a back and forth connection with my internal API server. Okay. And using the internal API server, it will write as well as read the required things from the PostgreSQL. So now scheduler is able to talk with my database. And now what scheduler is seeing, let's say it is seeing that this is the new DAG. So what it will do, it will say to internal API server that please create the DAG definition inside the metadata DB. I will write it here. Create a new tag run in metadata DB with some status. Status might be pending, queued, running, so anything, right? So now this is how scheduler is communicating with a Postgres database. Right now, scheduler has successfully stored all the information. It is able to read and write everything from my Postgres database using internal API server. Now, obviously, it needs to trigger some diagrams as well, right? Let's say your pipeline schedule time arrives. So what will happen is the request is routed through this internal API server to create a new DAG run inside the metadata DB with the status of either queued or running, right? So what happens? The web UI will reflect this status change by fetching the updated state from the internal API. So now web server also needs to communicate with this internal API. Then only it can update the status, right? So web server now is also communicating with the internal API. So any kind of changes web server will be doing once the internal API inform him to do the things. Now the scheduler will determine which specific tasks are ready to run based on the upstream dependencies. Okay. And the scheduler will identify a task instance that is ready and it will request internal API to change its state. Let's say as of now it is scheduled. Now scheduler will say to internal API that please change the status for that specific tag to queued. So it will come here as a queue. Once it came here in the queue, the scheduler then passes an execution request to the executor. So here one new link will be formed that is with the executor. So obviously executor will take all the requests provided by the schedules one by one, because as you already know that executor stores the information in the queue. So let me copy paste this one. So this is my execution queue. So executor will store this information. We had already discussed this thing. So it will store the information provided by my scheduler in a queue. So what scheduler is sending? It is sending my execution request. Let me write it down here as well. So now executor have its own execution queue ready, and let's say it's the time that it needs to trigger this task instance. Now executor is responsible for assigning the work to the actual computing resources, right? We just discussed here, which is worker. Executor takes this execution request from my control plane. This is my control plane. Let me write it down here. Control plane, because scheduler is controlling everything. So this is my control plane. So it will take all the requests from the control plane and it will hand over the task submission to the worker nodes. Let's create the worker nodes. Let's say this is my worker nodes 1 and 2 and 3. So it will hand over the execution request, which is in my queue, to these worker nodes. Yes. So now what will happen next is worker nodes start the process. It started processing everything. Whatever executor is saying, it is executing all the required tasks. Now what happened? There is a task which involves waiting from an external event. As we had discussed yesterday also, this Snowflake query should be finished, then only it can execute the remaining thing. So what it will do is, it will use the deferrable operator, which we had discussed yesterday, triggerer. Remember this one? It will use the deferrable operator. Let me drag some deferrable operator. Let's say this one. This one will be my triggerer. Now I guess you are very clear what I am doing and why I explained you the core components before we started the Airflow 3.0 architecture. That's the only reason. Now workers will go to this one saying that, hey, there are some couple of emails or couple of Snowflake queries which needs to be run before I start processing further things. So I am deferring this work to you. So it is like a deferrable operator. Okay, no problem. Triggerer is built for that only. So it will say, okay, no problem. I will take your task executions. Let me write that as well. It had taken the handover from the worker nodes. Now worker nodes can go and pick up the next task. Meanwhile, trigger will wait for that request. Let's say this one only, Snowflake 4 hours query running request. It will wait. And let's say it finished. After 4 hours, it finished. Now, what will happen is it won't go to worker nodes. Worker nodes will only communicate with the executor or with my internal API, because at last it need to inform the internal API that I am empty if everything is done, right? So it needs to communicate with the internal API. Now, triggerer had finished his work and it had retrieved the result from the Snowflake. Now, triggerer will create a event with the executor. It will inform the executor that, hey executor, the task assigned by worker is completed. So it will create an event which is known as event trigger, and it will report the status. I will write that as well for simplicity. It is like a status reporting. So it will report the status, either pass or failure or in progress, whatever. Once that is done, executor will again assign the task result in the queue, which is the execution queue. It will again go for processing based on first in, first out. So meanwhile, worker will keep on informing the internal API server about the status and everything. And API server will also be communicating with the Airflow UI about the changes, and everything is happening perfectly. Now, once worker runs the actual operator code, which obviously it needs to get from the DAG log storage, so it will create a connection with DAG log storage as well. So once it had ran all the Python codes present in my DAGs folder, the worker will report the status to my internal API. It will report the complete status, either pass or fail or whatever is the status. It will report the status to the internal API. And internal API will update the status in the Postgres sequence. This is the complete detailed Airflow 3.0 architecture. I hope now you are very clear about this architecture. But Jaswinder, there is one question. You said worker will be talking with the API, internal API server. What about executor? Won't it be talking with the internal API server? Good catch. Definitely it will talk with the internal API server, and it should talk with the API server, and it should update the API based task dispatch messages, right? So let me write it down here. It will be API based task dispatcher messages. Now, Jaswinder, one more question. One last question. Jaswinder, we discuss about two kind of queues: execution queues and Redis queues. You clearly told us that scheduler will be sending the execution request, and those requests will be storing in a queue. And we know that this is execution queue. But Jaswinder, where this Redis queue will sit? Redis queue will sit between the executor and the worker, and executor will keep on queuing the task so that any worker which is free can take the next task available. Oh, yes. So now this is the complete Airflow architecture. I hope we are very clear about this architecture. Earlier, before Airflow 3.0, there were a couple of parameters which used to directly talk with the Postgres. But this latest Airflow 3.0 architecture had eliminated that part. Now all the things will be happening with the internal API server. Internal API server will only and only allowed to talk with the Postgres SQL, or you can say your metadata DB, right? This is the most detailed Airflow architecture. I hope we are very clear about this now. Cool. Very good. Now, as we are very clear with the Apache Airflow 3.0 architecture, which also uses a sequential executor. So this was the default Apache Airflow architecture. But now dynamics had changed more. Now this Airflow 3.0 architecture is more advanced. And if I say more precisely, this is now 303 architecture. And inside this Airflow 3.3 architecture, we are not using sequential executor, because this whole process, this complete process was working with the sequential executor. But it is no longer true. Now this whole architecture works with salary executor. So what is this salary executor now? Salary executor is nothing, it's just the advanced version of sequential executor where it also allows you to scale your Airflow architecture horizontally as well. So if you have to scale architecture horizontally, let's say you need to add more schedulers or more workers or more Airflow UI, that flexibility is given with the salary executor. Oh, yes. So now, if I rename this, I will say Scalable Airflow 3.3 architecture. Okay, so let's now understand this. For that, obviously, I will literally copy paste this complete one because the enhancements happened on the existing architecture only. Now, let's understand the Scalable Airflow 3.3 architecture. The first thing in Scalable Airflow architecture is that you are having almost everything as the clusters. Okay, let's say instead of one UI, you might be having multiple UIs. Okay, and this will be a one cluster. Let's say this one. This is the one cluster. Inside this cluster, you will be having n number of Airflow UI. So I will say Airflow UI clusters. Okay, so this is the first thing. Second thing, now scheduler will not be single scheduler. We will be having ample amount of schedulers. So let's say I am having four schedulers as of now. Okay, but assume these are not four. These are, let's say, 100. Okay, so now you are having ample amount of scheduler which will support the control plane for scaling. Now if I talk about workers, we need to scale them as well, because as of now it is only having rigid three workers, but we are talking about scalable Airflow architecture where there will be millions of requests, millions of processes, millions of DAGs, millions of people and whatnot. So we need to have everything or most of the things as the scalable, right? So now we understood that Airflow UI will be scalable, then scheduler will be scalable, scheduler go to executor, we know that, and then after executor, workers are very limited because executor work is very simple. Even it's a scalable or not scalable, it will just keep on queuing the execution queue. So we don't need to scale the executor, but you can do that if you want. Okay, there is no constraint that you cannot have multiple executors, but as of now I am not scaling my executor because I am assuming that my request is increasing from hundreds to thousands. In order to handle thousands of requests, it's fine with the single executor as well. But again, I don't want to commit for the single executor. I am saying it's up to you. Okay. But for workers, definitely we need to scale. Now workers will be saying, hey bro, we are getting millions of request in the executor and our redis queue is getting long, and after a time, bro, if you don't took any action, I will go out of memory and I will die. So Airflow will say, no problem, I won't let you die. Okay, I will allow you to scale using the salary executor. Okay, so now these workers will create a connection, and that connection will be with salary executor, and that scaling request will be going to the salary executor or Kubernetes executor. Okay, it is flexible and it is up to you which executor you want, but I am mentioning both of the executor, that workers will be sending the scaling request to the salary or the Kubernetes executor. Now this will come into another box, and once the scaling request from the workers will be received by either of the executor, they will immediately go and raise this thing to the internal API server. Jaswinder, cannot workers talk with internal API because we already have a connection with internal API? I know we have a connection with internal API for the workers, but the thing is, workers only report status with the link. If there is anything related to scaling, Airflow team had built a special pool which we also called as worker pool. So any request which is related to scaling of the workers, those requests will go to worker pool. Now these worker pool will entertain the request for the workers, and it will talk with the internal API server to create a lot of workers, because the Redis queue is getting very, very big. Now, after the executor will talk with internal API will create a connection with the salary worker farm. Let me create that as well. So this request will be gone to the worker pool, or you can say salary worker farm, where we are having a lot of workers sitting and waiting to get started as per the requirement. Now here you can see that even the workers are divided into the sections. Some workers are get queued, so that if there is any additional worker needed, these workers will go there for the work. Some workers are designed to only work when the heavy ETL process is having. Some workers are for the core queue, and some workers are designed for the machine learning workflows which require a heavy amount of GPU. So a reason is, if worker will directly communicate with the API, it will only say that, hey, I need the worker. But if worker request the scaling to the salary executor or the Kubernetes executor, it won't just say to this internal API that create a worker. It will analyze the queue, and based on its analysis, it will say that I need heavy ETL workers, or I need queue worker, I need core worker, I need machine learning workers. Oh, yes, guys, this is the reason why workers are not allowed to directly communicate with the internal API, because they will pass vague information. But if worker is requesting the scaling request to the worker pool or the salary executor is very intelligent, and it will immediately analyze the Redis queue, and then it will create a structured request for the internal API server. And then if it says that I need a heavy ETL queue workers, so it will say, okay, so the request will be going like heavy ETL workers. So now, once this request will go, it will go to only the heavy ETL queue section. And among the heavy ETL workers, some of the workers will come here. Let me define that as well. And they will also start participating in minimizing the Redis queue. Now there is another challenge here. What is the challenge, Jaswinder? If you remember, these workers were communicating the status to the internal API, and then Airflow UI used to fetch the status from the internal API server. But now these can still send the status to internal API. But what about these workers? How they will send the status to the internal API? How? For that, Airflow people created a centralized log aggregation. So what will happen is, all the requests will go to a stack which is known as ELK stack. ELK stack. Okay. So if internal API require queue, it will go to queue. And once the queue finishes its work, it will report the logs to the ELK stack. Similarly, second queue will also report the logs to ELK stack. Third, also heavy ETL also will report the logs to ELK stack, and then core queues will also report, and then obviously ML queues will also be reporting to the status to the ELK stack. And you know what? This ELK stack is nothing just the combination of three processes. First is log stack, second is Elasticsearch, and third is Kibana. I had an image which can explain you more about the ELK stack pipeline, as you can see. So what happened? All the logs will go into ELK stack. ELK stands for log stack, Elasticsearch, and Kibana. E for Elasticsearch, L for Logstack, and K for Kibana. So what happens? All the logs will go to Logstack first. Log stack will process all the logs and it will enrich the logs, applying filters, applying any kind of timestamps or any kind of structurization. And then it will pass the request to the Elasticsearch in the JSON format. Elasticsearch will search and analyze the complete JSON file, and based on the analysis, it will store the results inside my metadata table. And once it had stored everything inside the metadata table, Kibana will come, it will see the metadata table, it will try to analyze and create a visualization or alerts or success triggers, whatever, and the output it will feed back to the Airflow UI. Oh, crazy. Yes, guys, this is really crazy one. But I hope I had explained you. Let me re-explain. So what happened in Scalable Airflow 3.3 architecture, they started using celery executors instead of sequential executor, which we had covered in Airflow 3.0 architecture. Because we need to scale it, we need to use celery executor, not sequential executor. So now, instead of having a single UI, we will be having a separate dedicated cluster which will only be handling the Airflow UIs. Then we will be having a separate cluster which will be handling only the schedulers. And these scheduler will keep on scaling as per the demand. And then we will be having the executor cluster as well. Inside the cluster, we can have a single executor, we can have multiple executors as per your use case. Then we will be having a cluster of workers. And if workers need more scaling, they will go to worker pool. And inside the worker pool, we will be having the celery executor or Kubernetes executor. They will understand the Redis queue and they will send the request to the internal API that these workers only I need. And once internal API receives the request that, okay, they need heavy ETL workers or they need normal workers, they need queue workers or they need machine learning workers or whatever other kind of workers, internal API will go to that section of the worker pool and it will request additional resources, and these resources will come here and work with the worker pool. But as these are part of separate cluster and these are part of separate cluster, they cannot altogether send the status to the internal API. And even if they come into the same cluster, imagine the number of status requests internal API will be handling. Already the internal API server is the main pillar. If I receive tons of requests, server will go down, right? So we obviously don't want that as well. So what will happen? They will come here to participate, and once the things are completed, they will go back and they will pass the logs to the ELK stack. And this stack will process your logs, enrich your log, create a JSON file, then Elasticsearch will analyze and store your JSON file inside the metadata. And then Kibana will create the output on top of that. And then Kibana will pass the output to the Airflow clusters. And now Airflow will be able to show you the statuses, the success, the failures, the timestamps, the queues, and whatnot. This is the most detailed, scalable architecture anyone had explained. So now you clearly know the Airflow 3.0 architecture, which works on the sequential executor, and the latest architecture, which works on celery executor, and you can scale that to any extent. And I am not saying that you cannot scale Airflow 3.0 architecture or before the architecture. The thing is, by default in the Docker compose.yaml file, you will be seeing the sequential executor. Let me show you. I will go to my Docker compose.yaml file, and here somewhere you will be seeing the celery executor. I will show you as well, no problem. See guys, so here you can see Airflow core executor is celery executor. But if you see any Docker compose.yaml file before Airflow 3, it will be showing sequential executor. Because I am working with Airflow 3.3 as of now, July 2026. This is the latest one, but there is a possibility that your Docker compose.yaml file will be of something of Airflow 2 point something or before Airflow 3. So you might see sequential executor. We will already be working on the salary executor, but you should know these things as well. Okay. This is all about Airflow scalable architecture. Jaswinder, one last question. Shoot. So workers are keep on scaling. They are coming to salary executor for the request. And it might require parallel task to be executed or distributed task to be executed. All the requests are going to the salary executor. Yes. But Jaswinder, where it is storing this information which it is retrieving? Very good. For that, we have a concept called flower. Let me use this and I will name this as flower. Okay. So for that, we have a concept called flower. So flower is a web-based tool which is used exclusively to monitor and administrator your salary executor. So it doesn't matter if you are using salary cluster for parallel or distributed task. Flower will provide you the real-time insights of the health of the worker pool, as well as the status, as well as the performance. And it will also show you if how many tasks are in queues and how many worker nodes are currently active. Okay, so it's kind of a complete build solution for the worker monitoring and task management. Jaswinder, where we can see this? Let me show you. So for that, first thing you need to go to your docker compose.yaml file, and inside this YAML file, you need to ensure that you have this flower image. If you have this flower image, you can literally see the flower on port 5555 on your Chrome or Edge or anywhere. So I will show you as well. So here you can see it is the local host 5555 and this is the salary and this is the flower instance. And you can see here, if I click on flower, I am having two salary workers. One is online and second is offline. And if I open any of the salary worker, you will be seeing couple of options. First is pool, which is mentioning the maximum concurrency. This means maximum concurrent sessions it can create. You can also mention the pool size. You can grow it or you can shrink it. Then you can also mention the auto scaling mode, the minimum number of workers you want always to be active or the maximum number of workers you want to spin. Then you have a broker, which is nothing just the Redis queue person who keep on pinging the Redis queue because it needs to understand the Redis queue, right? This worker needs to understand the Redis queue. So they understand the Redis queue using broker. Let me write that as well. Broker. Okay. So they are just understanding the Redis queue so that they can make a wise decision for the internal API server. Okay. Then we have queues. It will show how many of the tasks are in the queue, which is not our thing, which is obviously handled by Flower itself. Then we have task, how many tasks we have, limits, configs, which is also mentioning all the kind of configs. Yeah, then we have a system information, which is about this Flower. And we have workers and we have task and we have broker. And yeah, this is all about Flower. Now you know that how the salary executor or Kubernetes executor are working under the hood using Flower. Make sense? Perfect. Let's now start installing the Airflow in our system. For that, first thing we need to download and install the Docker. For that, I will go to my Chrome. I will say Docker download. I will go to the Docker website and here I will say download Docker for desktop and my desktop is Windows. So I will say download for Windows. And here I will just click on download and it will start downloading. It is very big. It's 600 MB. So it will take some time. So I will just fast forward here. Okay. Now I had downloaded the Docker on my system. But before installing the Docker, we need to do couple of things. First thing, we need to ensure that our system have enabled the virtualization. For that, I will go to Task Manager. And in Task Manager, you can go to this performance. and click here, and you can see the virtualization is enabled, which is good, which is really good. And second thing you need to do is you need to enable the Windows subsystem for Linux. By default, it is disabled, but you need to enable because without Linux, we can't properly work. For that, I will go to my search bar. I will say Windows feature on and off. As you can see, I will click enter. And here you need to enable two things. First thing is this virtual machine platform, which is already enabled, which is good. And second thing you need to enable is Windows subsystem for Linux. Click here, click on OK, and you had successfully enabled the Windows subsystem for Linux as well. Perfect. It is applying all the required changes. It might take a couple of seconds. So see guys, once it had applied all the changes, it will ask me to restart my system, which is very important. So let me come back once I restart my system. Once you had restarted your system, you need to install the Docker. Okay, you just need to click here and you need to run as administrator. But even before doing that, you need to open the PowerShell. Okay, and in PowerShell, you just need to check if you have WSL installed or not. You need to say WSL minus minus version. So you can see that I am having the WSL already installed in my system. But there is a probability that in your case, this is not installed. In order to install that, all you need to do is you just need to say WSL minus minus install and click on enter, and you will be able to install WSL. WSL stands for Windows Subsystem for Linux, and without this, you cannot work directly with Linux. And also, guys, let me show you one more thing. I will say WSL minus minus list minus V. So I can see I am having Docker as well as my Ubuntu on my system, right? So as of now, I can see my Docker is in stopped state. So it will go in running state because I will enable and start the Docker. But you should be having Ubuntu as well in your system. And if you don't have, you can literally install the Ubuntu as well. I am already having the Linux in my system. As you can see here, it is showing the Linux. So that's why I'm not installing it. I'm just giving you the helping hand so that you can just go and do these steps. Once you are done with these steps, you just need to install the Docker. Okay. And once you install the Docker, you need to come to Docker and sign in to your Docker. Once you sign in, you need to go to resources, and here you should be able to see you are using WSL2 backend. And if you are not able to see this, this means WSL is not installed on your system. You need to reinstall WSL on your systems. Perfect. Now as our Docker desktop is running, now I need to install the Airflow. In order to install the Airflow, I will use my favorite VS Code. And here I had created a folder, and inside the folder, I need to create 4 subfolder manually. This is something which you need to do manually. You need to create a config folder, you need to create a DAGs folder, you need to create a logs folder, and you need to create the plugins folder. Okay. If you work with a managed Apache Spark, then you don't need to worry about them. But as we are working on our local machine, we need to create these 4 folders. Cool. Once we had created all the folders, I will go to Google and I will go to Apache Airflow documentation. And from here, I will be downloading the Docker compose.yaml file. Okay. So I will click on this one and it will go and download this file. And once this file is downloaded, I need to place this file in the root folder here. So for that, I will go to my downloads. I will paste my Docker file inside my Airflow folder. And now I can see my Docker compose.yaml file here. Now, as you know, the Airflow core component as well as the Airflow architecture, this Docker compose.yaml file will be very easy to understand. Let me show you. If you see here, you will be seeing the Airflow configuration, and then you will be seeing in the services, which is my metadata database, we are having Postgres, right? And then if I go, we are having Redis, and you already know what is Redis. And then we have API server, and you know what API server means. This means the final Airflow interface, and it is hosted at port 8080, right? Then we have scheduler, and you already know what is scheduler. So this is why I explained you the complete architecture as well as the core components separately, so that you can understand when I will be opening this YAML file, you will be very clear that what this particular section will be doing. So this is again the scheduler, and then we have a DAG processor. You can see that it is having mentioned retries as 5. So this means it will keep on pooling for the maximum of 5 times, right? Then we have a worker, and I am not explaining this what is worker. Then triggerer also and then last it is airflow initialization. This is where airflow demands all the required configurations, all the required inputs from the users. Then we have airflow CLI. Last we have flowers. So flower is just an app which monitors the environment. That's it. Okay. And yes, that's all about Docker compose.yml file. Now, as we are clear about the very high level information of the Docker compose.yml file, we need to tweak this file a little bit. Okay. The first thing we need to do is we just need to go to Postgres and we need to do the port mapping, because Docker is running in the isolated environment, right? And my local system is running in a different environment. I need to map the port saying that my local port mapping should be same to the Docker port mapping. So for that, I will, after volumes, I will put ports and then I will click on enter. And on the same level, I will say 5432 5432. This is the default port for Postgres. And obviously, I need to put this in double quotes. So I will put that in double quotes. Another thing which I want to change here is I will go up and here, yeah, here I can see they had written Airflow core load examples. So by default, it is true. But I will do this false because I don't want the dummy Airflow jobs to be seen in my Airflow UI. Okay, so I had just made that false, and you can even make it true also. That's fine. The default one is true, but I don't want to see any unnecessary DAGs on my UI. Okay, so that's why I had made this false. Now, as we are done with both of the changes, I don't think there is something else which we need to do here. So now I will go to terminal and I will create a virtual environment. So for that, first I need to install UV, which is the latest Python package and it is very fast. Let me download it. Okay, so it is already there. Perfect. Now I will say UV init. I will click on enter and it will automatically create the virtual environment for me. See, it had successfully initiated the project Airflow. Now I will say UV sync and I will click on enter. Now I will say .venv. I will just initialize my virtual environment. Then I will say script. Then I will say activate and I will click on enter. And yes, it had activated my virtual environment. Now I will install the Airflow. For that, I just need to say UV add Apache Airflow. And I will click on enter and it will start installing all the required dependencies for the Apache Airflow. As there are 114 packages to install, I will fast forward here and I will come back once this is installed. Now it had successfully installed all the required 114 packages. It's the time to initiate the Docker. For that, I will say Docker compose up and then I will say -d and I will hit enter. And yes, this is what I want to show you. This command had failed because the fernet key is not set. Docker Compose relies heavily on .env file, which we had not created yet, to handle all the security and the user permissions. Okay, so let's create that .env file. I will click on this file and I will say .env and I will click enter. And inside this, I will create two things. First thing, I will mention my Airflow UID, which is default 50,000. And second is the fernet key. This is something which I had generated random. So for local working, that's fine. So you can mention this random one and I will click on save. Now, once again, I will run this command and let's see if this works or not. I will say docker compose up -d. Let's see. And yes, it started pulling the Airflow image, Redis image, Postgres image, and it will take 2-3 minutes. Let's wait for 2-3 minutes. Now Docker Compose had successfully ran everything. Now I will go to my Docker and I will show you that you can see that there is a stack of containers inside the Airflow. If I open, you can see that there are a lot of services which are initiated. And you can even see the Postgres is available on the port 5432, 5432 because we had manually done the port mapping for this one, right? Similarly, API is available on 8080, and you can see that all the services are up and running except this initialization service, because this service only gets up and running when we have to initialize other services. Once the other services go up, it automatically exit the environment. Now I will show you the Airflow UI. For that, I will just click on this port 8080, which is my local host port 8080, and this will open this interface. Here I need to pass my username and password. Okay, from where this username and password will come, I will take you to my YAML file, and here by default this YAML file have mentioned the username and password as Airflow. I will show you. See here, even in the Postgres it had mentioned the username and password as Airflow. And similarly, if I go to my UI here, you can see in the environment also the username and password is Airflow, right? You can change it obviously if you want, but I am okay with this existing username and password. I will go back to my port 8080, and here I will type my username as Airflow and password also is Airflow, and I will click on sign in. This is how the latest Apache Spark 3.3 UI looks like. They had changed a lot of things. Earlier it was having very standard UI. Now that is very flexible. We have a lot of options. We can see our tags, and as you can see, I'm not having any tags. Why? Because I had disabled this thing. If you remember this one, on line number uh yeah, on line number 865. I don't want any load examples. So that's why I'm not having any example tags available. Then we have assets. Okay. And then we have browse option for audit logs, XCOMs, and required action. We will cover that. Then we have an admin panel as well because we had created all those things. So we obviously will be having the admin pan. Then we have a connection option here, which is important. So this connection option is very helpful when you have to create a connection with the external providers like Snowflake, Athena, AWS, Blob, or whatnot. You have a lot of options here. Then we have the users, which is my profile, and you can obviously change the appearance from light mode to dark mode to whatever mode you want. I personally love dark mode, as you know, but yes. Then we have failed DAG option here, running DAG option here, and active DAGs option here. Because we had not created any DAGs as of now, we are not able to see anything. Then we have an option called manage pools. That's pretty much, guys, because we will keep on coming here when we will be creating our DAGs. So as of now, I am okay with this much of UI explanation, but obviously we will be exploring this in coming minutes, right? No problem. Well, let's now create our very first DAG. For that, I will go to my VS Code, and inside the DAGs folder, I will create a new file, my first dag.py. Okay. In order to work with DAG, we need to import a library which is airflow.sdk. And I want to import DAG as well as task. First thing, I need to define a function. Let's say my function name is first DAG. Okay. Now, before I move ahead, I want you to understand that if I just define a function, it will treat this as a function. But is this a function? No, right? This is not a function. This is a DAG which I am going to create. For that, I need to define a decorator which is known as @DAG. Now, this will be considered as a DAG. Okay, Jaswinder. So now this is DAG. What will be the name of this DAG, Jaswinder? Very good question. If I don't define any DAG ID inside the decorator tag, my function name will be my pipeline name. But if I define it, let me define it. I will say DAG ID is equal to pipeline underscore one. Now this is my pipeline name. If I don't define this, my pipeline name will be first DAG. But I need to define it, and actually this is the best practice to always define the relevant pipeline names. Now I am inside my function, and obviously I need to create some tasks. So for that, I will use a decorator named task. And here also, I need to define a task ID, which will be the name of this task. Let's say I name this task as job underscore one. Then I will define a task. Let's say task underscore 1, and then I will just print here, this is my demo T1. Then let's define another task, but another task I will define without the task ID so that you can see what I was talking. So I will say define task underscore 2, and then I will print here, this is my second task. Okay. Now I need to map these tasks. Okay. For that, I will create T1 and I will map T1 with my task underscore 1, and similarly T2 with my task underscore 2. Once this is done, I will come out and I will initialize my function. For that, I will create demo initializer and I will pass my function here, which is my first tag. Very good. Now, if I just run this, it will show me two tasks in my Airflow, but in parallel. Let me show you. Let me show you. Before showing that, I need to ensure that this tag had successfully parsed, and I can see that 11th of July folder is created and it has successfully parsed my tag.python into tag.python.log. So this means if I go to my Airflow, I should be able to see my tag as well as the two tasks which will be in parallel. Let me go and see if this is true. I will go to DAGs and here I can see my pipeline 1, and by default if you see it is disabled, and this is very good because if by default it is enabled, you might be having some dependencies which you really don't want to run right away, right? So this is very good. Now I will go inside my pipeline and I will see two tasks which is in parallel. And one more thing, if you notice here, I had named my first task as job 1, and here I can see that. But my second task, I had not named anything with task ID. So that's why I can see my second task as task underscore 2. Oh, yes, yes. Now these two tasks are in parallel, but I want them in the sequence. Very easy. All you need to do is after you define T1, T2, just mention the arrows that T1 should be running first, then T2 should be running. And save this and wait for 10 seconds so that it will parse my changes. And then I will go back. And here, if I just click on refresh, I should be able to see the task in the serialized way. We had successfully created both of the tasks. It's the very time that I should trigger this task. For that, I will just click on this trigger and see, guys, it had successfully ran both of my task 1 and task 2. And I can see the ran the duration, which was 2 seconds. And if I click on any task, I will also be able to see the logs. And I can see that the print statement, this is my demo T1. Similarly, if I click on task 2, I will also be able to see my print statement here as well. This is how we create the task and tags inside our VS Code, and that will reflect here automatically. Make sense? Now let's understand the versioning in DAGs. Yes, guys. So before Apache Airflow 3, if you change something in your code and save them, it was eventually going to overwrite your version of the previous code. So in order to avoid that, developers used to have some CI/CD in picture, but with the new Apache Airflow 3, they started maintaining the versions of your codes. So that if you had written some code and it failed in the production, you can immediately go back to the previous version of the codes. And yes, this was introduced in Apache Airflow 3. Okay, how we can implement that? Let me show you. For that, I will first click on this pipeline. I will go to this code. As of now, you can see the latest DAG version is version 1 because we don't have any other things, right? Now I am going to create the third task. Let me go here and let me define a third task. I will just copy paste this and yes, and I will name this as task 3. And here I will say third, and then I will define T3 as well. I will say T3 is equal to task underscore 3. Very good. I will save this and I will wait for a couple of seconds because it takes some time to refresh. Now, I will go back and I will refresh my Airflow UI, and you can see that the third task is now also there in my pipeline. Now, if I go to my code, you can see the latest DAG version now changed to version 2 because we had changed something in the existing DAG, right? Now, if I want to go back to version 1, all I need to do is you just need to select here version 1 and you can see the version 1 code. This is latest addition in Apache Airflow 3. By versioning, you can literally control all the failovers, all the accidental codes, which eventually leads to more failure and more overheads. So this reduced the developers overhead to create and maintain their own CI/CDs. Now you don't need to do that because Apache Airflow no longer is overwriting your codes. It is maintaining the versions of each and every code base. Now, there is another relevant term which is very much relevant to versioning, which is known as sync. By sync, I mean how DAGs are getting synced immediately with this UI. I know you are going to ask me this question, so that's why I am going to cover it in advance. Okay. The question is, Jaswinder, how the code which you had written in your local is getting reflected on this localhost 8080 Airflow UI? How it is working under the hood? Let's discuss that. Let's assume this is our state, and obviously this is our current state. So we are working in VS Code, and inside VS Code we had created 4 folders: config, DAGs, logs, and plugins. So everything is there in my local. Yes, Jaswinder, we know everything you are doing in local. Now, we had also installed Docker, right? Let me drag the Docker icon. Yes, Jaswinder, we had also downloaded Docker and all the things are hosted on Docker. Very good. Now, inside the Docker, we also have some folders. Okay. Jaswinder, we know that inside the Docker, we have couple of containers, but you are now saying that inside the Docker, we are also having some subfolders. Yes. And those folders are like OPT, then Airflow. Now, I will make it big. Now, this code is getting synced with my Docker using a concept called bind mount. What is the concept? Bind mount. Jaswinder, what is bind mount now? Okay, no problem. So, bind mount is nothing just a mechanism that allows us to link our local code with the Docker. Let me write it down here. Bind mount is nothing just a storage mechanism that allows us to link our VS code. Okay, let's simplify this. VS code with Docker. Oh, so this is happening because we have a concept called bind mount, which is mounting all the things inside my Docker. Exactly, guys. Now, just in the how and where it is mounting, that's where I told you that it gets mounted inside OPT slash Airflow slash the respective folder name. If my folder in my local is DAX, it will create a OPT slash Airflow slash DAC. If my folder name is config, it will create opt slash airflow slash config. Let me show you. Here I am into my Docker and I will open couple of containers so that you can see that what I am saying is true in every container. Let's open this one, DAG processor. Here you will get the option called bind mount. If you click on this option, you will see that from my local C drive, it had mounted the things for the logs folder into opt slash airflow slash logs. Similarly for config, it had created config folder. Similarly for plugins and DAGs, it had created opt slash airflow slash the respective folder. Okay, let me show you 2, 3 more. Now let's go to scheduler. Here also if I go to bind mount, you will see the same thing. Let me open API server as well. Bind mount, same thing. Let me open one more worker, let's say, bind mount, same thing. This is how your DAGs are getting synced with your Airflow UI using Docker. Clear? Very good. Now you know that once you create your DAG, it creates the logs. Now it also started creating a DAG ID, pipeline 1 and run ID and task because we started running our DAGs. So when you start running your DAGs, it also creates some additional metadata as well. So this is what it is creating. Then we have a config file where we have all the informations about the config like DAG bag import timeout, something which is very generic to the Airflow. Okay, you can change this config. Usually I don't change it, but it's again depend on the project to project requirement. But yes, now you know how we create our very first DAG using VS Code, Docker, and how it gets reflected and how DAGs are getting synced immediately. We also covered the versioning as well, right? Very good. Let's now discuss about the operators in Apache Airflow. Operators are nothing just the reusable template that you can use within your task. That's it. I don't want to complicate the definition of operators because it is literally a reusable template which you can call or define within your task. Okay. So we will cover two kind of operators. First is batch operator and second is SQL operator. Okay. So for that, I first need to import some libraries. For that, I will say from airflow.sdk, import obviously DAG and task. Now I need to import bash operator from airflow.providers. So for that, I will say from airflow.providers.standard.operators.bash. And what I want to import? I want to import bash operator. Now I need to define a DAG. As you know, always I will say @decorator DAG, and I will give this pipeline name as DAG ID is equal to pipeline underscore operator. Okay. Now I will define a function which, let's say, operators demo. Here, first I will create a bash operator variable. So I will say, let's say my name Jaswinder is equal to bash operator. Then inside this, I will mention the bash operator name. For that, I need to use task ID. And let's say my bash operator name is pinging data to dollars. Okay. Now I will mention my bash command, and my bash command is echo and my YouTube URL. Very good. Yes. Now all I need to do is I just need to initialize my function. I will just copy and paste it here. And yes, that's all, guys. I had literally defined my bash operator and I had initiated. Now I will save this. I will wait for a minute so that it refresh my DAG processor as well. Once it will refresh, I will go to my Airflow. I will refresh it and I can see my pipeline operator and I can see pinging data to dollars task. Let me trigger this task. I will trigger this and it started running. And yes, it had successfully ran. If I open this and I show you the task log, you can see that it had successfully echoed the output as the URL from for my YouTube channel. Cool. Now let's define the other operator, which is SQLite operator. For that, obviously, first thing I need to import the SQLite. I will say import SQLite 3. This is the latest SQLite. Now we need to define a task. Let's create a task. I will say @task and then my task ID, which is, let's say, load SQL. Very good. Now I will create a function. I will say define run SQL query. Now I need to connect it directly with my local file inside the container. For that, I need to create a path. I will say db path and I will mention my Docker path. I will say opt airflow and then let's say airflow.db because I am doing it in local. Now I need to mention the connection. I will say con is equal to SQLite 3 dot connect with my this path, which is db path. Now I need to mention the cursor. As you already know that cursor is very important. I will say connection dot cursor and now my cursor is also defined. Now let's execute the statement. For that, I just need to say cursor.execute, right? I will say cursor.execute. And now I need to mention the 3 quotes. And here I will first create a table. I will say create table if not exist. And I will name this as demo TBL. And here I will create 2 columns. First column, let's say report date, which is my, let's say, text. Now I will also mention user sign up, let's say anything. And let's not give this text, let's give it integer. Now I need to put colon and I will come out. Now I need to also add some inserts. So I will say cursor dot execute again. And now I will mention my insert scripts. So I will say insert into my demo TBL and on what columns? Both the columns. I will mention both the columns, which is report date, control C and control V. And second column is user sign up, control C and control V. Very good. Now I need to mention the values. I will say values, and here I will pass the date of now, which is my current date. And also I will pass some value, let's say 150. Now I will close this, and I had inserted as well. Now I will commit this. I will say con.commit. Okay, no problem. Now I had committed my insert scripts as well. Now within this function only, I will also print something. Let's print that SQL query executed. Okay. In this way, it will be very easy. If anything fails for us, we can debug that. SQL query executed. Now I will also execute the select statement. For that, you know what I need to do. I need to do cursor.execute. And now I need to mention my select query. My select query will be on this table. I will say select star from this demo table and put here, and I will say select star from demo table. Now I need to also fetch the rows. So I will say rows is equal to cursor dot fetch all. In this way I can fetch all the rows, and I had stored the results inside my rows column. I will do one funny thing. Okay. I will add comma, 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 so that it will look like a fancy thing. So how I will do that? It's very simple and it's little stupid as well. I will say backslash n and I will add a plus. Then I will say equal to, because I need equal to. How many times I need? I need equal to 40 times, let's say. Okay, so in this way, it will be having a 40 times equal to, equal to, equal to, equal to, equal to. So it will look very good. So I will say print next statement. And in next statement, I will say data now. Then I will again print the same thing. I will say print equal to, and I will multiply by 40. Now it will look very beautiful. I had stored my results inside the rows. So I need to iterate on these rows, right? For that, I will say for row in rows. So now I will iterate. So I will say print, and I need to mention f string because I need to use this row now. So I will say date, and then I will just pass this row of 0 because the first column is date column, and I will add a pipe, and then I will mention the other column, which is sign ups. Sign ups. And here I need to pass my second column. For that, I will say row of 1. So in this way, I got both the columns. And yes, yeah, that pretty much. So now I will just say con.close, and it will close this loop as well, which we started. And yes, now I will create the dependency. First, I will run this one, Jaswinder one. I will copy, paste it here. Indentation is very important, guys. I only get indentation error when I work with Airflow. Now, I need to mention this one as well. Yes, so I will mention here. That's pretty much it. Now I will save this one. I will run this one and I will wait for a 10-20 seconds so that all the changes get refreshed in my log file as well. And yes, let me go to Airflow now. I am into my Airflow. I will go to pipeline operator and I can see both load SQL and pinging data to dollars. Let me click here and let me also see its code. I will go to code. I just want to see that if this is the latest code or not. Yes, this is the latest code. So now all I just need to do is I just need to click on trigger. I will trigger this, and inside the logs only I should be able to see my results. See guys, both of them ran successfully. I will go to this load SQL and I will click on this post execute. And here you can see the data now because I had inserted some comma, 40 commas, 40 equal to and 40 equal to before and after. Here I can see the entry which it had taken from my table, which was demo table. So this is how you can work with SQL operator as well. Now we had worked with SQL operator as well as with the bash operator. So this is how we work with operators in Airflow. Let's now understand the XCOMs in Airflow. XCOMs act as a cross communication between the task. Let's say you have some value in task 1 and you want to pass that value to task 2. How you can do that? You can do that using XCOMs in Airflow so that the first task is communicating with the second task. The output of the first task will become the input for my second task. Cool. Let me create a new Python file. I will click here and I will say xcoms.py. As always, first thing first, I will import DAG and task from Airflow. So I will say from airflow.sdk, import DAG and task. Very good. Now I will define a DAG. I will call a decorator DAG. I will give this DAG ID as XCOM pipeline. Now let's create a function. I will say task flow XCOM, and now inside this I will create task. I will say @task, and here I will define another function. Let's say generate data. I will try to pass some dummy data here. I will say generate data, and then I will print generating. Now let's return some data. So here I am returning data in the form of dictionary. So I will create a dictionary, and the key I will say is processed records, and the value here I will pass is, let's say, anything. Now the status, let's say another column, and let's say status is success. Now I need to pass this task to my second task. Let me define the second task as well. I will say @task, and my second task, let's say process data. I want to process the generated data. How we can do that? First thing, here in the function I will pass my dictionary. So I will name this as, let's say, Jaswinder, and then I will say dictionary. Now I will also print something. I will say print, and then I will pass f string, and I will say received. Let's say, okay, what I had received is, I will pass here, I had received a variable named Jaswinder value. Now I will try to fetch this one. For that, you already know how we do that in Python. I will create a variable, and I will pass referenced variable, and then the key. Key is processed records. So I will pass my key here. Now I had created my second task as well. Now obviously I need to set up the dependencies, correct? So let's say my dependency variable name is pooled metrics, and I will assign this variable this function. And similarly, I will directly use this function, and inside this function I will pass this variable. This is how we work with Python, right? It's nothing new. And I will say pulled metrics. Yes. And obviously at last I just need to call this tag. I will just copy here and paste it outside, and yes. And this is done. So now we had defined the dependency. This is one way to do that. Here, we are directly calling the first function in our second function using a variable, right? And then we are calling the tag. This is the automatic way to define XCOM. Now my XCOM file has been successfully parsed, and I can see my xcom.py.log on my 12th of July folder. Now if I go to my Airflow and I refresh this, and I will be able to see my XCOM pipeline, and as you can see, I can see it. I will click on this, and I will try to run this time. Again, I will trigger this, and yes, very good. Both of them had ran successfully. Now let me go inside one, and I will go to storage, and here I will go to XCOM. And you will see that it had returned me a value with the status, which is a key pair of status and process records. And if I go to my second process one, now if I go to render template, you can see that it had successfully fetched both of the values. And even if I go to logs, you will be able to see here as well. So you can see here. So it had successfully received both of the values. And here I had not defined any arrow kind of dependency in my Python script, because I am referencing the first function in the second function. So this is automatically defining the dependency. This is one way to work with XCOM. There is second way, which is a manual way to work with XCOM. And let me show you that as well. Now here only what I will do is I will comment these two, and I will define here only, so that you can get a single template. Okay. Now, this was the automatic way, and it's the time to understand the manual way. I will give the heading as manual way. So now, obviously, first thing I need to create a task. Let me copy paste both of my functions entirely, and I will use both of the functions here. Okay. I will uncomment them. Yes. Very good. Now, instead of generate data, I will say generate manual data, so that you can understand that these are manual XCOMs. Now, I need to import a function which is known as get current context, because we need to get the current task instance context to work with XCOM. For that, I will go up, and here I will say from airflow dot operators dot python import get current context. Now I will pass this context here. So I will create a variable, let's say jazz, and I will say get current context. Now I will pass this context to a task instance. For that, I will say ti, I will say context of ti. And what is ti? Ti is the task instance, and this is something which is default word provided by this context library. Okay, now we need to manually push this data, right? So for that, I will just remove this one, and I will put this as the first statement. And now I will remove return as well. Instead of return, I will say ti dot xcom push. Then I will mention the push name, which is my key name. If I go back to my Airflow and I open this generate data, and if I go to storage and XCOMs, you can see the default key name is return value. But now I am going to change this return value to something else. So here in key, we can do that by passing any relevant name. So let's say it's my custom matrix. Now I need to pass the value, right? So for value, I will just copy paste this return because obviously this is my value. Control C and Control V here, and yes, this is how I had defined my first task. Now it's time to work with second task. Similarly, in the second task, I will again copy paste these two. Here I will remove this print statement, and after this one, I will also remove this part. Now I need to pull these XCOMs because in my first function I had pushed the XCOMs. So obviously I need to pull the XCOMs as well, right? So here I will create a second variable, let's say Jaswinder, and then I will say ti.xcom pull. Make sense? Very good. Now I need to pull based on the task ID. Which task ID I need to pull? So I need to pull this task ID, generate manual data. So I will mention this task ID here. Then I need to mention my key. So which is my key? Custom matrix is my key. So I will pass this key here. And yes, I had successfully pulled the data using the original task ID and the key in my Jaswinder variable. Now, first thing I will print the received one. So I will say print f string received Jaswinder variable. Now I will also say if Jaswinder. This means if value is present inside the Jaswinder variable. Then again, I will just copy paste from here this one. I will say if value is present in Jaswinder, this means Jaswinder variable is not empty. Then I will store this record and I will also print this record. I will just print off f string successfully processed records. And if the Jaswinder variable is empty, then I will just say empty. Now, because we had manually pulled and pushed the XCOM value, we also required to define the dependency, right? So here I will define the dependency. First will come this generate manual data, Control C, Control V, then double arrows, and then the process data. This should work as expected. I will save this and I will wait 10-20 seconds so that it get refreshed inside my log folder as well. Now let's go to Airflow and I will refresh this. And this time I am seeing an error, which is good. I should be able to see errors as well. So error is saying missing keyword argument Jaswinder. Okay. Yeah, I know this error. Oh, yeah. See, guys. So here this should not be coming because now it is manually pushing and manually pulling. Let me resave this and let me refresh this. I will close this and I will refresh. Yes. And now I can see my XCOM pipeline back. And if I open this time, if I go to code, you will see that code is also got updated to with XCOM push and XCOM pull, and the version I am seeing is version 2, which we had discussed that how Airflow is maintaining versioning now from Apache Airflow 3 onwards. Now let's run this and see if this is only rendered or this is even okay to run. I had triggered the run. It failed. Very good. It failed saying that context is not defined. Yeah, makes sense to me. Let me go back to my VS Code And yeah, it was giving error, but I just ignored this. No problem, I will remove this one. And here I cannot just pass context like that. I just need to pass that as skvax. Here also I will pass this one, and I will remove this one. Now I guess this should work. Yes, it looks promising. Let me go back and refresh. I will go back to code to see if the changes are reflected. Yes, I can see the changes. Now let me try to trigger this again. Trigger. Okay, first code passed. Again, second code failed. Why this code failed? Let's understand. XCOM pull got an exception with argument task ID. Did you mean task IDs? Yes, yes, I mean task IDs. Let me just add S as well. Task IDs. Very good. Let me save this again. Let me go back to Airflow and let me refresh. Let me go to code to see if the task ID is updated. Yes. Let me trigger this again. So now both of my tasks are passed. If I go to my first task and then if I go to storage and if I go to XCOM, now you will see earlier the key was return value. Now I had changed that name to custom matrix. And inside the value, I can see my past value. Similarly, if I go to second one, I will be able to see that it had received both of my values and it had successfully processed the value as well, which we had passed, right? This is how we work with manual XCOMs. It's up to you if you want to just define the dependencies directly with using the functions. You can do that also. But if you want to manually write XCOM push and XCOM pull to create or share the variables, this is also good. Okay, it's up to the use case, or it's up to the users understanding which way user feel that it's easy. Okay, very good. Let's discuss about the another important concept which is very commonly used when we are building the airflow pipelines, that is known as parallel tasks and branching. So I guess it is self-explanatory what I mean by parallel task, but I will still show you retrofitting the branching in the same diagram. Okay, let's say this is the task 1, then you have a task 2, and this task 1 is the first task. Then we have task 2, task 3, and task 4 in parallel. And then we are checking the condition here. Okay, let's say some if condition we are checking here. And if the condition is true, then we will be taking some appropriate action. So here, if is working as conditional branching. Now I will show you how to implement that as well. But you should be very clear about the normal task and how we can create the task before I go with this thing. Okay. So now you know that this is a parallel task. You already know it's not something which I am explaining. This is self-explanatory. And branching, now you know that branching means some condition, some kind of parameters which is required before the final task gets executed. Now let's implement this as well. First thing, I will close this XCOM file and I will create one another file, and I will name this file as parallel tasks and branch.py. I will save this file, and obviously first thing I need to import task and DAG. I will say from airflow.sdk import DAG and task, right? Now I will create a DAG. I will define a decorator of DAG, and I will name this as, I will give this DAG ID, and I will name this as parallel tasks and branching. Now I will define that function. I will say define, let's say, pipeline demo. Yes. Now inside this, obviously I will create some task. First, I will create a task which will be for fetching the data. Okay. So I will create a function. I will say define fetch data. And here I will print the statement saying fetching data from source dot dot dot. And now I will return something. I will say return as a dictionary, and I will say record count, let's say, and anything, let's say 2500. And then I will also print the, let's say, status again, let's say ready. This time not success, let's say ready. Now I will create a conditional branching task. Okay, I will just give a heading as conditional branching task. In order to create a branching task, we need to use @task dot branch. This is the operator which is provided by Airflow by default. Task dot branch. Okay, and this operator allows us to create the branching task. Now let's create the branching task as well. I will say define, let's say check quality of the branch, maybe. Okay, and now inside this I need to pass my data, and obviously the data should be passed in the form of dictionary. First thing, I will create a variable count, and I will store the value of record count. I will say count is equal to data of, copy paste here, record count. Very good. Now I will print that as well, just to debug purposes if everything is working fine. I will say evaluating quality for this count records. Okay, because this is a data quality function. So let's write something meaningful. Perfect. Now I will define a condition. I will say if the count is less than 1000, then I will print it's a low data volume. Okay, and I will return this as well. I will say return low volume alert. Okay, but if the count is greater than 1000, then I will again print high data volume, and then I will return that as well. I will say high volume alert, and then I will return the list of tasks which will tell my Airflow to execute them in the parallel. Okay, as of now I hadn't created that task, so let's first create those tasks. So I will come here and I will create both of the task. I will say @task, and I will define first task as low volume alert. Okay, and then I will just print here warning received low data, let's say. Okay, anything. So yeah, similarly I will create second task as well, which will be for high volume alert. I will say define high volume alert. Why I defined this low volume alert is because I am returning the low volume alert. So once I return this low volume alert, I want this task to be executed. That's the only reason I had created this low volume alert. Now I need to create something for this one, and let's create that, and let me pass first some name so that I can use the same name. Let's say process segment A. Okay, and then similarly I will copy this and say B. Just quickly I will just do this. Yes, now let's create both of these tasks as well. Okay, because I'm returning this as the dependency of the task. Again I will define @task, and these two tasks going to be parallel task, right? So let me give that heading as well. I will say hashtag parallel tasks. Very good. Now I need to define both of these. I will copy and paste it here. And yes, inside this, I will again print something. I will say processing A, let's say. And similarly, I will copy paste this below, and I will name this as segment underscore B, and I will say processing B. Perfect. Now I had created everything in the parallel task. Now I need to join these parallel paths as well, right? Are you understanding, right? Let me go to another screen and let me show you what I mean, okay? I don't know how much you are getting it. So it's better that I explain you. So I will just copy and paste it here. The first task I had created is fetch data, right? This is my first task. Now after this task, I had created a second task, which is a quality check branch. Okay, quality check branch. I will make this bigger. Yes. So this is my second task. Then I had created three tasks. First is segment A, segment B, and volume, low volume alert. And by the way, all of these are parallel tasks. So I will just copy this name and I will paste it here. This is my low volume alert, let's say. Similarly, this is my process segment A. Oops, here. And this is my process segment B. This is what I am creating. Okay. Now, after this, what I had done is I had created, I will remove this one. I had created a join summary, which will be encapsulating the final results here. Okay. So, this is what I am creating at the moment. So, it's better that I explained in this way so that you know what I am doing. Very good. Now, clear? Perfect. Let me make this little bit bigger. Yes. Now I will go back. I had created this one. I will highlight it in green. This one also I had created. I will highlight this one as green. This one also is created. This one will also go green. This one is also created. This will also go green, and this one is also created. Now I need to create my join summary, right? Which is nothing, just joining the parallel task to get the relevant answers. Okay. Now I will go back, and yes, now I will create a joining parallel paths task. I will name this as joining parallel paths. Okay. Now I will again define a task. And here inside this task, I will pass the trigger rule. Trigger rule ensures that this whole stuff runs. Okay. Either the alert should get trigger, or either the parallel processing task should finish successfully. So this is the trigger rule I am going to pass. The trigger rule name is none failed, min one success. So this will ensure that either the alert is getting triggered, or the parallel task of segment A and segment B are getting triggered. Okay. So this is the trigger rule. Let me copy paste and do that inside my diagram as well. I will mention this here. Yes. Very good. So I had mentioned my trigger rule. Now I will create a function. I will say define join summary. Very good. And let's print something. Let's say pipeline execution completed. I need to create the dependencies now. Everything is done and dusted. Okay. If I just run till this time, I will be able to see all the things except the dependencies, right? Because I had not defined any dependencies yet. So this is the last step which we usually do, as you already know, which is defining the dependencies, right? Let's define couple of dependencies. First dependency is on fetch data. I will create a variable, let's say upstream data, and I will assign this fetch data function to this one. Now I will create a second variable, which is my branch decision. And in this, I will assign this one, check quality branch. I will copy, and check quality branch also demands a parameter, which parameter is coming from fetch data. So I need to ensure that as well. So I will first copy this one, and then I need to pass the parameter. And the parameter is this one, upstream data. I will pass it here. Yes. So first two dependencies are done. Now I need to define the individual paths out of this branch, right? So for that, I will again give a heading. This is all about defining the dependencies. Okay. I will say define individual paths out of the branches, because we had created three branches, right? Yes. So first is my low volume alert, second is my process segment A, and third is my process segment B. So this means I need to create the three variables. So I will create it, no problem. I will say alert path, alert underscore path, and I will copy this variable and paste it here. Yes. Similarly, I will create a second variable, which I name this as, let's say, parallel path A, and I will just use this one. Similarly, I will copy this one only, and I will just change A to B, A to B, and A to B. Very good. Now I had defined all the variables. It's the very time to actually create the arrow dependencies, right? So first thing, I will create a dependency for the branch decision. Okay. I will copy, I will paste it here. But Jaswinder, why you are not creating dependency for this upstream data first? Because I had passed my upstream data as a reference in my branch decision. So even I create it or even I don't create it, that don't make any difference. Okay, so that's why I'm ignoring it. Now, after branch decision, what I need to pass? I need to pass these three, right? I will copy and keep on pasting alert path first, then parallel path A, then parallel path B. Very good. Now, after this is done, I want to have the join summary as well, right? So I will assign that here. I will say, I will just copy paste. Very good. And this is done and dusted. Now I will just call this pipeline. My pipeline name is pipeline demo. Yes, I will call this and I will save this. It might take a couple of seconds to get refreshed, so we will wait, no problem. It had successfully parsed my Python file and I can see in my log. Let me go to my Airflow and let me refresh it. As of now, I'm seeing 4 tags. So once I refresh it, I should be able to see either the error or either the 5 tags. Let's see what it get. Oh, I got the error. Very good. So error is the key parallel task has to be made alphanumeric dashes, dots, and underscore exclusively. Makes sense. Fair point. Let me do that. No problem. So I will come here and I will just add underscore parallel task underscore branching. I will save this again. I will refresh this again. I will go back and I will close this and I will again refresh this. Yes. Now I am able to see parallel task branching as well. I will open this one and I will show you. This is exactly what I explained you, right? Let me show you that as well. See guys, fetch data, quality check branch, process segment A, B alert, and then join summary. And this is exactly what it had created. Fetch data, quality check, process segment A, B alert, and join summary, right? Now, we had defined the parallel processing as well as the conditional branching. It's a time to run and see if this is even running. Hopefully, this should run, but if this is failing, no problem, we will fix this. Yes, see guys, it had successfully ran, but as you know, the records was 2500, which I had passed initially. So it is greater than 1000. That's the reason it had skipped this low volume alert and it had ran everything else, right? Now, you know that how we work with parallel processings and branching. Let me reduce it to 250 and show you that as well. I will again save this. I will just refresh this. I will go back. I will go back to DAGs. I will refresh this and I will go to parallel task branching. I will see the code if this is updated. Yes, it is updated. So now if this time I will run, these two will be skipped and this will be processed. Let me trigger this. See guys, these two got skipped, this code processed. This is how we work with parallel processing and branching in the Airflow. Let's now understand everything about the scheduling. And scheduling is again a very crucial part of Airflow because obviously, whatever pipelines you will be building, at last you need to schedule it, right? How the scheduling works is, let me copy paste this one and I will control C and here I will say control V. I will remove this and I will put this inside a yes. So now let's say this pipeline is scheduled. Okay, and you know what is scheduling, right? Scheduling is nothing, it's just orchestrating your job based on the business times, right? This is our scheduler and we had scheduled our job. Okay, and let's say you had scheduled your job daily. So now what will happen? Let's say today is 1st of January 2026. Okay, if you schedule this job on 1st of January 2026, it won't run on 1st of January 2026. It will run after the 1st of January 2026 is completed. This means it will run on 2nd of January so that all the data which potentially can come on 1st of January, everything will get processed in a one go. This is the default behavior of scheduler if we apply at the rate daily. Make sense? Very good. Now, Jaswinder, where we need to define daily first, at least tell us this also. So you need to define everything about scheduling inside the DAG decorator only. So when you mention at the rate DAG, you need to define your scheduler. And you, obviously you need to define the start date, which is mandatory to define. Then you need to define the schedule, which is also mandatory to define. The third thing is catch up, which is optional if you want to do catch up. Catch up means if you missed backfilling for couple of days, and if you say catch up is equal to true, it will eventually process the data for those missing days as well. Okay, so this is the principle of catch up. It is very helpful for historical loading as well. Cool. So now there is fourth one as well, which is known as end date. I am not going to mention about end date because usually in 99% cases, we never mention the end date for the DAG. Okay, we just mention the start date, schedule, and sometimes we also mention the catch ups. Okay, I know start date and schedule is very clear to you, but I will write the definition of catch up for you guys. Let me simplify catch up now. I will write here. I will make this big. I don't know why this is very small. Yes. So I will write here the easiest, simplest definition of catch up. Okay. I will say Airflow looks at the gap between your start date and current date. Okay. And it will notice all the periods that were missed and instantly, okay, instantly fires off or run off historical runs to catch up. Okay, this is the simplest definition I can write for the catch up. Okay, so basically Airflow will look for your start date. Let me change the color. Start date, and it will look for the current date, and it will see if between the start date and the current date any days of schedule missed. If it found any misses, it will immediately run the missing dates interval as well. This is all about catch up. Okay, perfect. Now we discuss about the scheduling, how we can define the scheduling, and what is the definition of catch up. Now I will also explain you the types of scheduling in Airflow. I will just copy here, and instead of scheduling I will say types of scheduling. So basically there are four types of scheduling available in the Airflow. First one is cron preset. Let me create a box, and here I will say cron preset. This is the very first type of scheduling. It is very simple. It is usually a standard cadence. Okay, here we define either at the rate hourly. Okay, it's very simple. At the rate daily or at the rate weekly. These things we can define here. Okay, so this is my first type of scheduling where we can just define the preset of the cron and it will keep on running based on the presets. Second type of scheduling is standard cron expression. Standard cron expressions. Okay. Using standard cron expressions also we can schedule, and you already know what is cron. If you don't know what is cron, just type on Google what is cron, and you will be able to see that cron is a time-based scheduler, and you can even search cron creator and you will get a lot of things. And this is my personal favorite, cron tab guru, and here you can get your cron based on your requirement. Okay, so this is cron. Cron is nothing, just expression which you pass. It give you actually more flexibility than just going with daily, hourly and weekly. Okay, so this is a next level of cron preset. Okay, now I will go back, and you know what is cron expression. I will just copy paste this one for your reference. Yes, very good. So this is my second type of scheduling. Now comes the third type of scheduling, which is my time delta scheduling. Time delta. If you need a task to execute purely relative to the time rather than any fixed clock boundary, you need to use time delta object there. Let's say you want to run something precisely 30 minutes after your previous run finishes. Then you need to define the time delta because you don't know when will be your previous run will get complete, right? Sometime it might take, let's say, 10 minutes. Sometime it might take 10 minutes, 15 seconds. So you don't know. In that scenario, you need to mention the time delta. Okay. And for time delta, you need to use date time library. I will write it here as well. date time library. And this library is very helpful when you need to deal with time delta. Very good. Now there is a fourth kind of scheduling as well. And this is the final type of scheduling. And this scheduling is known as asset based scheduling. What is this asset based scheduling, Jaswinder? Let's say you are having a upstream dependency with some external storage where it is required to update a file or where it is required the new file to be landing. In that case, you will be using asset based scheduling because you cannot schedule the cron preset. You don't know the file is coming regularly or weekly or monthly or when. You cannot have a standard cron extension because that also demands the timings. You cannot have a time delta because you don't know when the file will be arriving on your source. So this is where asset based scheduling come, that whenever the file will arrive in my respective cloud provider or respective location, then only trigger this schedule. This is the advanced type of scheduling, which is also known as event driven scheduling. So these are the four types of scheduling which is now available in Apache Airflow 3. Make sense? Now let's deep dive and do hands on all the things which we had discussed. Let's begin with the first type, which is cron preset. Right? I will create a new tag and I will name this as scheduling.py. Okay. And I will use this one only. I will keep on adding and commenting the previous ones. Okay. Let's create it. For that, obviously, first thing I need to import is DAG and task. For that, I need to say from airflow.sdk import DAG and task. Very good. Now I need to import the date time library as well. I will say from date time import date time. You can also use pendulum as well. Many developers prefer pendulum as well. And it's up to you. Coming back to the discussion. Now I need to define a decorator of DAG. I will say @DAG. And here, as we discussed, we need to pass the scheduling parameters. Okay. The first thing, as I always pass, is DAG ID. DAG ID means the name. So I will say scheduled method. I will say cron preset. Right. This is what we are doing. Yes. Now I will mention the start date. Start date is equal to date time. I will mention yesterday's date. Date time of 2026, 7 of 11. Because today is 12th of July. So I will mention yesterday's date. And obviously I need to put comma, else I will get error. Yes, very good. Now I need to mention the schedule, and schedule for this is daily. I will say @daily. Now I need to mention the last and optional thing, which is catch up. Do I want to catch up? Let's say false. Okay, let's first try with false. Yes. And now I will define my function. I will say define, let's say cron preset DAG, and here inside this I will create a task. Obviously I will say @task. I will define a very simple task. I will say define run daily. Okay, and I will just say print running cron preset. Very good. Yes. Now obviously at last I need to call this. I will say run daily. And then outside I need to call my tag. I will say cron preset tag. And yes, this is how I define my first tag. I will save this, and now I will wait for the time it will refresh in my tag processor. Now my scheduling log has successfully parsed. I will go to my Airflow and I will just refresh this. Now instead of 5 tags, I should be able to see 6, or either I should be able to see error. So I am seeing 6. This means very good. So this is my scheduled method cron preset. I will open this and you can see here in other schedules it is empty, but here it is mentioned the schedule, which is everyday daily. 0000 means daily at 12 a.m. in the night. Okay, I will open this. I just open this and you can see the schedule, and it is saying at 00 of every day, right? This is how you can schedule the things. Okay, because it's or it's not 12 a.m., so it's not running for today. But if I change this, then it will start running. Okay. As of now, if I go to runs, there are no runs because this is the newly scheduled. Let me go back and I will change this date, and I will change catch up is equal to true. As I had mentioned yesterday date, and today is 12th of July, eventually this should have a one catch up run, right? So let me do catch up is equal to true. Let me save this file, and I will go back to my Airflow. I will go back to DAGs, and eventually you will see there will be a one run. Obviously, I need to enable this, and I will just refresh this and see, guys, it had ran successfully. And if I go back, you will be able to see two runs. Why two runs? Because it need to catch up from 11th to 12th today. So it had ran both time, and you can see it is scheduled. It is not manual run. If I just run this manually right now, you will see the third run, which is manual. I will show you that as well. We'll go back, I will go to runs, and you will see the third run is manual run. But other two are scheduled. And why these two ran? Because I had just mentioned the catch up is equal to true, and it started catching up from my 11th of July to today, which is 12th of July. And you can clearly see that it started from 11th of July, and then it ran till 12th of July today 5:30 a.m. This is how it works. This is the first method, which is cron preset method. Let me go back and let me comment this method, and I will go to second method now. I will just comment this method. And as you know, the second method is custom cron expressions, right? So obviously I will also comment this for you guys. No problem. I will rewrite this. I will copy paste it and I will rewrite it. Yes. I will uncomment this. And here instead of cron preset, I will say cron expressions. Now first thing is start date. For that I need to obviously mention the date time, which is correct. Now the main change here is in the schedule. Okay. Here in the schedule, I need to mention the cron. Okay. So for cron, it is very easy because you don't need to remember the cron. You just need to go to Google and type any cron thing. And here you can see this is cron guru, and it is saying it runs at 4 5 a.m. If I just add 0 and 0, you will see that it run at every day at 12 a.m. of the night. Okay. If I just say 1, it runs at every day at 12:0 a.m. Okay, let's do that. I will copy this cron and I will come back here and I will just paste it here. Okay, and then everything looks good to me. Everything else looks good to me. I will mention catch up is equal to false. I don't want to run this again because I had shown you how you can use the catch ups. Now I will again define a function, or maybe I can just copy paste this function only because eventually it's same, right? So I will just uncomment this. I will just change here cron preset to cron expression. And here I will just say cron expression. Yes, that's it. Let me save this and let me go back to my Airflow. I will go back to Airflow. I will go back to tags and I will just refresh it. And now my name should be expressions. Very good. And it is showing that it runs every day at 0001, right? And yes, and there is one more thing, guys. If you notice, by default all the schedules are disabled, but I want to enable it when when I'm just creating it. There might be scenario you want to do that. That's very easy. Just say is post on creation is equal to false. That's it. Done. Now if I go back and if I refresh this, you will be able to see that this is already scheduled. Let me go back where, okay, there is one error. No problem. We'll see the error. Catch up is equal to false. Okay. Oh, I hadn't put the comma. No problem. I will put the comma there. I will again save this and I will go back and I will close this and I will refresh this. Yes. Now if I go down, you can see this is now scheduled automatically. I hadn't enabled it, right? This is how you can enable the schedules by default if you want. Okay, again, if you want. So I will go inside. I will again show you that as of now, there is no runs. and this is version 1 and it is scheduled every day at 12:01 a.m. Make sense? Very good. Now let's do the third type as well. For that, I will again copy paste this complete code. I will just comment this code. Okay. Now I need to change here schedule method cron expressions to schedule method time delta. Okay. Now here inside the schedule, you need to mention the time delta. For that, just remove this and add here time delta. Time delta of how many minutes. Let's say I want in minutes and I want 45 minutes maybe. Okay. Yes. Now this is showing error because obviously I might not. Yes. I need to import this. No problem. Done. Now this error should be gone. Yes, this is gone. Similar way, here also I will say cron delta DAG maybe, or time delta DAG. Time delta DAG. I will copy paste here as well. And here I will say running time delta. Yeah, that's it. Done. Okay. It is done. It is saved. I will go back to my Airflow and I will go back to DAGs and I will refresh this. And now inside the schedule, you can see inside the schedule, it is saying it is scheduled as a cloud. You can see it is mentioning cloud, but in the upper it was mentioning the time. Now it is mentioning the cloud. This means it will only run when the previous had ran successfully. And yeah, you can see it had already ran once. I will show you. I will open this, I will go to runs, and you can see it had already ran once because there was no previous dependencies. This is how we can work with time delta. Okay, very good. Now let's discuss about asset based scheduling as well. For that, first thing I need to import asset here, and then I need to create a variable for the asset. Let's say I create a variable name Jaswinder. Okay, then I need to pass the asset, and inside the asset I need to pass my S3 location because in my case I am going to use S3 location. So I need to pass the S3 location, but I don't have any S3 location. So I need to first create the things in AWS. First, I need to create some IAM roles and all those things in AWS. So I will quickly go and create them and I will show you as well. If you have AWS account or Azure account, you can follow along with me. If you don't have, no problem. You can just binge watch this concept. Okay. First thing, you can just search on IAM and click on the IAM. Then here you need to click on IAM users. Then here you need to click on create the user. Okay. Here you need to mention the username. Let's say I name this Airflow local user. Then I will click on next. And here I will click on attach policies directly. And from the policies, I will select Amazon S3 full access. I will click on this policy and then I will click on next. And yes, I will just click on create user. Now my user is created. I will click on view user and this is my user. Here I can see an option called create access key. I will click on this access key because in order to create a connection with my Airflow, I need access key. If I go to Airflow and if I go to admin and here if I go to connections, I need to create a connection, right? With the AWS. If I select AWS, I need to mention the AWS key ID and secret key. That's what I am going to create now. Okay. I will come back here and here I will select local code because I'm working with local VS Code and Docker. So I need to select local code. Then I will click on confirmation and then I will click on next. Now I will mention some tag value if I want. I don't, I can say yes and I can just click on create access keys. So it had successfully created my access key and secret key. So I will just copy my access key and I will paste it in my notepad. Then I will also copy my secret key and I will also paste this inside my notepad. Once my access keys are created, here I can see the option called download as CSV. I will just click here and it will download as CSV, which I had already downloaded. Now I will go back to my VS Code and here I will go into my .env file because this is where I am mentioning all the credentials. Here I will just store my access key, secret key and region and let me copy paste. Yes. Then I will click on save and I had saved my access key. Now I will go to my Docker compose file and here inside my environment, this one, I will add my AWS details as well. Yes, now I will save this file. Once I save this file, I need to restart my Docker. For that, I will say Docker compose down I will click enter and it will start stopping all of my services. Then I will type docker compose up minus d and it will restart my Docker. Yes, now my Docker had restarted. Now I will go to my Airflow. I will click on admin and here I will click on connections. Okay, and here I will add a new connection and I will name this connection ID as AWS default, let's say. And then I will mention the connection type as AWS. And now I need to mention my access key and secret key, which I had copied. I had mentioned both of my access key and secret key, and then I will click on save. Now I need to install the Amazon provider package. For that, I will just mention them in my .v env file and it will automatically be installed during the runtime. Okay. Now again, I will just restart my Docker. I will come here and I will say Docker compose down and then I will say Docker compose up. Once we had restarted our Docker, I will go back to my Airflow. Okay. And then I will click on this button. This is the test connection button. This will show me if my connection is successful or not. And as you can see, my connection is successful and I am able to retrieve the information from my S3 bucket. Very good. Now my connection is successfully tested. It's the very time that I go to my VS Code and create a Python script which will read the file from my S3 bucket and show me the results. For that, obviously, first I will go to my S3 bucket. I will create a new bucket. I will name this as Airflow Demo IMP. And yes, I will click on create bucket. Yes, I had created my bucket. Here I will place a txt file. I have already placed a txt file inside my Airflow directory. So I will use this txt file. I will go back to my VS Code and first thing first, I will create a separate file because this is not the schedule testing. We will also come to the asset schedule testing. But I want to show you that how you can read the file. Let me create a new file for that. We will come back to that scheduling part. No problem. So I will say read s3 file.py because this is also important, right? Yes. Now I will say from airflow.sdk dot import. What I need to import? You already know tags and tasks. Once I imported this, I need to import S3 hook. Okay, so for that I will say from airflow dot providers dot amazon dot aws dot hooks dot s3. This is the path, and from here I want to import S3 hooks. Very good. Now I need to import datetime as well. From datetime, import datetime, or you can even skip this. That's fine. We are not learning asset scheduling as of now, but I just imported it. Okay. Anyway, now I need to mention my bucket name. Bucket name, and my bucket name is Airflow Demo IMP. I will copy and paste it there. Yes. Now I will mention after this, I will mention my S3 key. S3 key, I mean maybe S3 path, you can also say. S3 path means this path, Airflow and simple. I will copy paste and yes, I will just remove this one because it should be Airflow slash simple.txt. Very nice. Now I need to create a DAG. Obviously, I will say at the rate DAG and I don't mention anything other than DAG ID and I will say DAG ID is equal to read S3 files. And one more thing which I want to mention here is tags because we are talking about AWS. So it's important to have tags and it is recommended actually. You can say S3. That's fine. Both of them are fine as of now. Yes. Now. Now I will define the function. I will say define S3 reader pipeline or anything. Yes. Inside this, I need to create a task. I will say at the rate task and then I need to define function, right? So I will say define fetch s3 content, anything which you like, and then I will just use print and I will say connecting dot and now I will mention my variable. I will name this as s3 hook and then I will pass my s3 actual hook, s3 hook, And inside this, I need to pass my AWS connection. So I will say AWS connection ID, which in my case was, if I go here and if I show you, it was AWS default. I will copy and I will paste that here. Very nice. Yes. Now I will say, I will also try to print if the file exists or not. So I will say if not s3 hook dot check for key, check for key, and here it will be checking for the key which is my s3 underscore key, and I also need to pass my bucket name. So I will say bucket name is equal to bucket name is equal to bucket name. Yes. So if the file is not present inside this means it is empty. In that case, just raise a file not found error. I will say file not found error, and I will just give f string, and I will say the file, and just say s3 key is not present. Very good. Else, if the file is present, then I will try to get the file content. I will say file content is equal to s3 hook dot read my file. I will say read the key, and I will pass my key, which is obviously my s3 underscore key, and then I will also pass my bucket name. That's it. Done. Bucket name is equal to bucket name. Very good. Now everything is done. All I need to say is I will just print some stupid equal to's, and then I will just print the file content. Say file content, and yes, this should work. Now I will again print this one as well. I will copy paste this function because I need to call this function, and I will say here call this function, then I need to call my tag as well, mention here, and yes, this should work. Let me save this file and let's wait for a minute till the file get parsed in my logs. Now my s3 file.python has successfully parsed. I will go to my Airflow and I will refresh my Airflow. And here I should be able to see the S3 path, and I can see that read S3 files pipeline is created. I will enable this. I will go inside this, and I am able to see fetch S3 content. I will try to trigger this. There is a high possibility it might fail, but let's see. Hopefully this should pass, but if this fails, no problem, we will fix this. It failed as expected, no problem. What's the error? The error is S3 hook is not defined. Oh, S3 underscore hook, Jaswinder. Let's go back to the code and see. Okay, here, no problem. I will put S3 underscore and I will just reparse this, and I will go back and I will refresh and I will go to code to see if the changes are reflected. Yes. Now let's try to trigger this again. Hopefully this should work. Yes, it had successfully ran. Let me open this one and let me go to my post execution. And here you can see the sample txt file is provided by all the details which is present in my txt file. Let me open my txt file. This is the simple.txt file which we had uploaded, and you can see the content is of lorem, it's ipson, blah 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 till the resources. And I can literally see the same content here, lorem, it's some something something till the resources. So this is how you can work with external providers, and I had shown you now as well. Even though this was not part of the scheduling, but I had literally shown you. Now let's go back to the scheduling notebook and let's try to understand now what is asset based scheduling. Yes, now I am back into my scheduling. Now I will create a asset template for you. For that, obviously I had imported the asset. Now I also need to import this one S3 hook. I will just copy and paste in my scheduling.python as well. Perfect. Now, here, first thing I need to create the asset. And I had shown you how we can create it. You can create a variable, and inside the asset, you need to pass your asset path. And I will quickly go to my S3 and I will copy this URI path. I will come back here and I will paste this here. Okay. And inside that, I am having a simple.txt file. I need to create that as well. This is how you can pass the asset path. Once the asset path is defined, let's create a DAG. That's it. I will mention a DAG ID. I will say DAG ID is equal to AWS S3 asset based scheduling. Very good. And obviously, this is kind of scheduling. So we need to mention some schedules. So I will say start date is equal to, I will mention start date time of something past. Let's say 9th of July. Then I will mention the schedule, and schedule I will say it's hourly at the rate hourly. And obviously I need to put in double quotes. Yes. And if I want, I can also mention catch up, and let's say it's false. Yes. Now obviously I need to create a function, right? So let me copy paste this function only. I will just copy paste this function, control C and then control V. And that's it, guys. This is how we work with the asset based scheduling. So whenever there will be a change or there will be a new file, it will immediately trigger these assets. This is how we work with. I'm not running it because I have already shown you how you can read the file from S3. So only anyway, I just copy paste this S3 code. So there is some issues, but you have to understand the scheduling here, right? Not the code. Because the code part I had just explained you in this read S3 file. This topic is of scheduling, but don't worry, we will be circling back on this in next 1 hour, because we are going to create an end-to-end Airflow project. There we will be loading the data as well. Okay. So yes, this is how we can work with asset-based scheduling. Okay. This is the main part for you. And this code I had already explained you. Cool. Very good. And this is how the overall scheduling work. Now you are very clear about cron preset, standard cron expression, time delta, and asset-based scheduling. This is all about scheduling. There is nothing else in the scheduling which is required to be covered. Make sense? Very good. Now, as we had discussed a lot about scheduling, now let's also discuss about how we can incrementally load the data. Because obviously, every time you don't want to do truncate and reload. And if you say that by this scheduling will not be this handled, my answer is no. You need to define the two variables which are date interval start and date interval end. If you don't define these variables, you won't be able to incrementally load the data. These variables will store your incremental dates. Okay. Let's say ran first time from 1999 to 260711. Okay. And let's say this is my first run. And now I had done the complete backfill. Okay. Because this is my start date and this is my end date. Let me make this little bit more beautiful. This is the first run. Now what will happen? When the second run will get triggered, it will store the previous end date as my next day start date. And then it will keep on running. Okay, let's say second day is today's date 12th. So this is how it will incrementally run. Oh, yes, guys. So this is how incremental data loading. Now let me show you how we can create the incremental data loading pipelines as well. I will go to my VS Code and yeah, let me comment this because scheduling it is just a demo. Save this. Yes. So now I will create another DAG. I will click on plus and I will name this as incremental load.py. Okay. And yes, first thing, obviously, I need to import task and DAG. For that, I will say from airflow.sdk import DAG, task. And then I need to import date time. So I will say from date time, import date time. Perfect. Now, obviously, I need to define the DAG decorator. I will say at the rate DAG. Then I need to mention the DAG ID. And let's say automatic incremental pipeline. Perfect. Then I need to mention the start date as date time of 2026 7/11, and then I will mention the, and let's say it's daily. Perfect. Now I will define the incremental function. I will say define incremental demo. Yes. And then I need to create a task. I will say at the rate task, and I will define a task. I will say define extract record. Yes. And inside this one, I need to pass two variables. Okay. And those variables are nothing, just the data interval, data or date. I guess data. But I guess I had written here date. Oh, sorry. Sorry, guys. It's not date, it's data. My bad. No problem. Yes. So it should be data interval start, and initially I will put this as none, and then we need to say data interval, and these two parameters will be storing your incremental values, and you don't need to worry about how they are doing it. They actually do it for you. Okay, just say that they do it for now. Let's say you are fetching data from SQL Server or Snowflake or any data warehouse. So obviously you need to fetch the data incrementally, right? That's why I'm explaining this incremental loading, right? So how you can do that? For that, we just need to create a variable, any name is fine. I will say incremental query. And inside this variable, obviously you need to create the connections the way we had created the connection with S3. I had shown you. You can do that using Airflow connections, and you know how to create the connections. So let's say the query is select star from orders table, something. And now here you need to mention the where condition, where order dt, let's say, greater than equal to, and then you will pass the incremental start date, and you know this is how you work, right, in with incremental. And then order dt less than the data interval and the data interval end. That's it, done. So this is how we work with incremental data. Nothing complicated or nothing very exceptional, right? It's usual thing which we do as a developer. Right? Now I will print this variable as well so that you can. I need to take care of indentation, bro. Yes. So I will say print my incremental query. Perfect. Now again close this function. Now again call this function and call this demo. That's it. Let me run this. I had saved it. So now after saving, it will go for parsing. Let me refresh and see if data is parsed. My pipeline is parsed or not. Go down. Okay. Now I can see my incremental load Python script is parsed. Is the time that I will go to my Airflow and I will go to DAGs and I should refresh. And here I can see my incremental pipeline. And yeah, I will click here and I will run. It had ran successfully. So I will open the post, and you can see here it had mentioned the order date as greater than 12 and less than none. This means all the data which is greater than the 12, and there is no data because as per this code it was yesterday 11th. So it is considering the maximum as 11 to 12. There is no data, so but it is displaying you how incremental flows work, right? Perfect. Let's now discuss about assets. Asset concept is very relevant to the scheduling, but instead of time-based scheduling, we do event-driven scheduling, or more specifically, if I say data-aware scheduling. Okay, so let me write it down. Assets are data awareness schedule. Let me make this big as well. I'm not sure why this is small. Yeah. So assets are data awareness scheduling. What this means? Let me show you with an example. Let's say this is the producer. Okay. Producer can be anyone, maybe external providers or anything. Let's say your producer is inside the Airflow environment. So he had produced something and he or she had stored the information on S3. Okay. Now, once the information is stored in the S3, then we will be having a consumer which will be consuming, right? Consume. So, we never know or when this file will be processed by the producer from any API. Let's say he is fetching data from some API, and let's say it's Drive API. Okay, he is trying to fetch data from Drive API, and using Airflow he is creating the files in the S3, and then the consumer is reporting on these files. That is actually a good use case. Yeah, then the consumer is reporting on these files. So consumer cannot directly report on these files till the time producer had not fetched the data and loaded the data into the S3, right? So in order to ensure this kind of scenario, Airflow introduced assets. Okay. So that's why I said that assets are data awareness scheduling. This means once the data gets into my S3, which will become my first asset, then only the second DAG will start processing the data. This is very important to understand, and this is not easy to understand. You might get confused. So if you are getting confused, please rewatch it. But I had tried to explain it in a very simplistic way, that it's all about producer and consumer. When you have a dependency of your data with the next DAGs, that dependency should be handled by assets, so that the next trigger will be happening only after the dependency is fulfilled. Make sense? Let's now see assets in action. For that, I will go to my Airflow, and this time I will say close all. And this time I will be creating three files. Note 1, note 2, yeah, three files. The first file will be S3 file config, where I will be mentioning the configuration of my S3. And here I will pass my code which we had literally used in this one, read S3 py. So same code I had mentioned here, and I will save this. And here I had mentioned asset. Why? Because I want this asset to be fully loaded before it goes to next tag. Okay. So this is the beauty of asset. Earlier also I had mentioned asset, I guess. Okay, no problem. So yeah, so this is how I had created my config file. Now I will create a producer tag. Okay. So I will create another file. I will say producer.py. Okay. And inside this again, I need to import libraries. I will say from airflow.sdk import tag and task. Then I need to import S3 hook as well. So I will just copy paste. I will open this one and I will copy paste. Yes, I had imported my S3 hook as well. And then I will import datetime as well. I will say from datetime, import datetime. Yes. And now, fourth thing, I need to import my this complete Python file into my producer.python file. Okay. How I can do that? I can just say from S3 file config, which is my file name, this file name, I will say import all the variables. Three variables I am having: bucket name, S3 key, and S3 asset. I will copy paste one by one. S3 data asset. Second one is bucket name, copy paste. And the third one is my S3 key. Let me copy paste that as well. Very good. This is how we can import other Python files into the existing Python file. Okay. Now it's the time to create the DAG. I will say at the rate DAG. Then obviously you know what we need to do. DAG ID, right? I will say DAG ID is asset producer pipeline. And then I need to mention some start date. I will mention some start date, because anyway I'm going to trigger it manually. It doesn't matter if I even mention it none, that's fine. But I will mention today's as a start date. Yes. Now I need to mention the schedule, and I really don't want to schedule this. I will say none. Then let's mention tags, because mentioning tags is considered as a best practice. I will say producer. Okay. Yeah, that is fine. Very good. Now we will create a function. I will say define producer workflow. Okay. And obviously I need to create a task. And now inside the task, I will mention outlets. Outlets. Jaswinder, what is outlets now? This is something new. Outlets is a parameter you can use inside the task, and the main purpose of this outlet is to just to declare whether the task is either producing or updating a specific piece of data. Jaswinder, what? We still hadn't understood what is outlet. Okay. Okay. So if you have to update your asset, if you have to make some specific piece of data, if you have to produce a new file, there is a parameter which is known as outlet. Oh, yes. Let me write the definition provided by Airflow. An outlet is a parameter used inside a task to declare that the task produces or updates a specific piece of data. Make sense? Perfect. Now let's come back to the discussion. Now inside the outlet, I need to mention the task or the asset, right? What is my asset? My asset is S3 data asset, right? You can see here I had mentioned the asset, right? So my asset name is S3 data asset. Let me copy and let me just paste it here inside the square braces. This is how we define the outlet. Okay, perfect. Yes. Now let's move on and define a function. I will say define upload raw file. And yes, now I will sprint connecting to AWS so that I can see in the logs if anything is failing. Connecting to AWS dot dot dot. That is fine. Now you know how we can connect with AWS. We just discussed here in read S3. We need to use S3 hook, right? And exactly we need to use this one. S3 hook is equal to S3 hook AWS con and AWS default. Let me copy and paste this inside my producer. Okay. Now I am going to create a dynamic string message which I will be writing. Okay. So I will say payload is equal to f string, and I will say something, I will talk something about my channel. Let's say I will say data to dollars production run, and then I can mention some date also. Let's say extracted at, and let's mention date time dot now. Very good. Yes. Now let's also print one more message, and I will say uploading sir. Okay, perfect, perfect. Yes. So this is also done. Now we need to use the S3 hook to load the data, right? So I will say S3 underscore hook dot load underscore string, which will be requiring some parameters. First parameter it asks, I guess, for string data, right? Something. Let me check. Yeah, string data, no problem. So then it asks for the key, and in my case, this is S3 key, and then it will ask for the bucket name, and bucket name is bucket name. Yes. And the last, if you want to replace the existing file or note, I will say yes, I want to replace the existing file, because if I go to my AWS, let me go here in AWS, I am already having a simple .txt file, right? But if I open this file here, you can see the simple .txt file is having some other text, lorem ipsum, blah, blah, blah. But now this text should be replaced by this data to dollar production run text, right? That's why I am saying replace is equal to true. Okay. Once this is done, I want a message saying upload is successful. Just see. Okay, done. Now I will just call this function, and I will also call this tag. Here, yeah, yes, this looks promising. This is how we created the producer tag. Okay, I will save this one. Now I will create the consumer tag. Okay, I will create the second file. I will say consumer.py. Now again, I will copy paste all the libraries present inside my producer in the consumer to save some time. Then obviously I need to create a tag. Why don't I will copy the tag as well? I will just change this tag. Copy paste, and instead of producer, I will say consumer, and date is fine. This is fine. Yeah, this is not fine, Jaswinder. This is not fine. Okay, but let me change consumer first. Instead of schedule is equal to none, I need to pass my asset name, because this is dependent, right? I first need to update my S3 with my producer. What happened? I first need to update my asset with the producer. I need to be dependent for my S3 bucket to get refreshed, right? So here schedule will be my S3 data asset. This will get refreshed first, then only this consumer should run. This is what we discussed, right? Consumer will go to S3, and then once S3 is refreshed, then consumer will do something. So this is what we are doing. Makes sense. Now let's define a function. I will say consumer underscore workflow, and obviously I will create a task. I will say at the rate task, and then I will define a function. I will say define process new file, and yeah, I will first print consumer waiting for asset notification. Okay, because obviously it will wait. Once asset notified, it will again say s3 underscore hook, and it will say s3 hook, and then I will pass my AWS credentials, which are AWS underscore default. Very good. Now I will mention another print statement saying fetching data dot dot dot. Very good, Jaswinder. You are going so fast. Okay, no problem. I will go slow. Okay, now what next? I need to read the content, right? So I will create a variable. I will say file content, and I will say S3 hook. Please allow me to read the keys. And my key name is S3 key, and my bucket name is bucket name, not buffer error. Bucket name. Yes. So once it reads the content, I want this to print the content. For that, first I will just add some equal to because I really love to distinguish. Yes. Now I will say print my file content. I will say f string file content, and then I will mention the file content, file underscore content. And I guess this should work. Let me call my child function, then let me call my consumer workflow. Yes, I guess we are good with consumer as well. So this is how we create the producers and consumers and the config files. I'm not running this. I am leaving this up to you guys because I know you can do that. The most important thing was how you can use the assets. And now you know how we can utilize the assets, right? Very good. Now it's the very time that we take the next step and implement a end-to-end solution for the Airflow. I will name this as a project. So what we are going to build is I will use a API. Let's say this is my API. So I will use any API. And in this case, I will be using the countries API, where I will be having the details about the countries, their people, and all the general details about the country. Okay. So I will be using a countries API, and then I will be pulling this data inside my Airflow. Let's say this is my Airflow. So using Airflow, I will be pulling all the data for the countries API, and then I will push this data to Snowflake. Let me drag Snowflake icon as well. Yes, very good. So I will create a table. I will push the data into Snowflake. Then what I will do, I will again use Airflow, and I will fetch the data from the Snowflake, and I will store this data in the S3 as the CSV file. Sounds exciting, right? Yes, this is exactly what we are going to build. Okay, we will be fetching the country's API data using Airflow. Then we will be loading the data into the Snowflake table. And once the data is loaded into the Snowflake, then again I will use Airflow, and I will convert this data into a CSV file and load that CSV file into S3. I will write here convert into CSV. This is exactly what we are going to build. Okay, very good. For that, obviously, I need this country's API URL, and somehow I code this URL from internet. This is the open source URL which I will be using in this. We are having a JSON file. So it will look more exciting because we are pulling the data as a JSON format, then we are storing the data after transforming the data into a table compatible way. Then after that, we are eventually using Airflow again and storing the data in S3 as the CSV. This will be very fun to do, right? Let's do that. And I hope you are very clear what project we are going to implement now. In order to implement this project, I had taken next step as well. What is next step, Jaswinder? I had literally created the new folder, Airflow Snowflake S3 demo, and that previous where we was discussing all the topics, I had separated that thing. I had configured my Docker. I will show you Docker as well. So you can see the Airflow one is now in stop state, but now Airflow Snowflake demo is now in my start state. So you already know how we can do that, and we had seen that when we was configuring. So all things you need to do is you just need to install Docker. Before installing Docker, you just need to see if virtualization is enabled or not. Then you need to see if VM is active or not. Then you need to install the Docker. Then you need to see if WSL is installed in your system or not. If not installed, install it, restart your system, then come to VS Code, create the folder, create the four DAGs, logs, plugins, and config. Then set up the virtual environment, then export the docker.yaml file, create the env file, and you are good to go to say docker compose up minus d. And you already know all these things because I had literally covered everything in the Airflow setup. If you want to redo that, just rewatch that part and you will be very good. Now, I had created a Python file which is end-to-end data pipeline, and let me go to Airflow as well. I will go to my Airflow and I can and you can see that at the moment I am having 0 DAGs because now everything I am starting again from scratch. I am just skipping the Airflow setup part. All the other things I will be doing from scratch. And you can literally see, guys, how detailed this project is going to be. I'm not just using the Airflow as an orchestrator tool. I am literally loading the data, and even I am transforming the data. So this will be the very, very helpful project. If you just do this project once with me, you will be someone who will be knowing a lot about Airflow. You will be someone who is not someone who can just orchestrate the jobs using Airflow. You will be someone who can load the data, schedule the data, orchestrate the pipelines as well. This will be the very detailed project which we are going to make, trust me. And what are the prerequisites? Because I'm using Snowflake, so I obviously need to run some scripts on Snowflake. So the prerequisite is that you should have some knowledge on Snowflake. But don't worry, if you don't have any knowledge on Snowflake, then also it's fine. I will explain you. Okay, it will hardly take 10 more minutes. That's fine for me. Before I jump and start writing the code, I had configured three things. Okay, Jaswinder, what three things you had configured? The first thing is I created the Snowflake trial account. And don't worry what I had written here because I told you I will explain you. No problem. So I had just created the Snowflake trial account. And if you want to create the Snowflake free trial account, all you need to do is you just need to type Snowflake free trial. Then you need to go to this option, and here you just need to provide your details, and then it will ask for the validation of OTP. And once this is done, you will also be able to see this interface. Okay. So this is the first thing which I had created, 30 days of free trial. And you can see today only I had created. So today it's showing that 30-day free trial. Second thing which I had done is I had created a new bucket because this bucket we had used for our demo thing. But this bucket will be used for this project. And you will see here the folders will be creating, here the files will be coming because of this project which we are going to implement. Okay. What's the third thing, Jaswinder? Third thing is I had added the connections because I need to connect my Airflow with the S3 as well as my Snowflake. Then only Airflow can load the data from API to Snowflake and fetch the data from Snowflake to S3, right? So I need to create these two connections. So that's what I had created. I had gone to admin, I had clicked on the connections, and here I had defined both of my AWS and Snowflake connection. And you already know how you can create the connection, but don't worry, I will just explain you again. Just click on this add connection, just type your connection name, then select the connection type. Let's say, because in my case it is AWS, I will select AWS. Then you need to pass your access key and secret key, and this is done for your AWS. Similarly, you can select your Snowflake here. This is our Snowflake, and here you need to pass your login, password, port, schema, and all the details which you can easily get in the Snowflake. Then you need to click on save, and once you save this will come. Now what you need to do is you need to test them. So here you can see your option called test connection. I will click on both the options, and if I see Wi-Fi icon here, this means both of the connections are successfully established, and you can see the test connections had successfully established. Jaswinder, these are the only three things which we need to do. First, have a Snowflake account, then create S3 bucket or S3 user, then go to IE, then go to Airflow and create the connection. Yes, but there is one additional thing which I had shown earlier, and but I cannot show you now, and that is creating of .env file. And this is the file where you will be having all the credentials or the username and password stored, right? So I cannot show you, but you know how to configure the env file. Even though if you don't know, all you need to do here is you need to pass AWS details which you are passing inside this connection. Let me show you again. Let's say the connection is AWS. So what is asking? It is asking for AWS key ID and AWS secret key. So you need to just create two variables inside this .env file with the AWS key ID, and second will be AWS secret. Okay. Similar way, you need to pass the things for Snowflake. For what's for Snowflake? In Snowflake, there are a couple of things. Let me select Snowflake. You need to pass host, login, password, port, and schema. And you can pass this. I am not going to pass this. My main motive is to let you know how to configure that .env file. And never ever share your .env file with anyone, because you know all the passwords are there. Anyway, now it's the very time that we start working on coding part. As you know, whenever we start with any kind of pipeline creation, first we need to import DAGs and tasks, right? So let me import. I will say from airflow.sdk import DAG and task. Very good. Now I will import date time as well. From date time import date time, and I will also keep on importing other things. Let's say time delta I will import. Okay, with the time I will keep on importing the things. Okay, as of now I am just importing these two things. Okay, now I will create the default argument dictionary. Okay, I will say default argument, and don't worry, I will tell you why I am creating this default argument dictionary. As of now, just bear with me. First thing I will just mention, let's say owner. Okay, you can mention anything, it's just a dictionary, right? The purpose of this I will tell you after, but as of now, just bear with me that you are going to create a dictionary. And there is a function which is known as depend on past. Don't worry, don't worry, we will come to that. But as of now, just understand this DAG is dependent on any past DAG. My answer is false. Then I am going to store the start date as well. Okay, and start date, and I will say date time of 26 2026 11. Okay, I will also pass retries. Let's say this job failed because it eventually might fail, and retries. I will say one retry. Yes. And you can also mention retry delay. That's why I imported time delta, and I will retry after every 5 minutes. Minutes is equal to 5. Very good. This is done. I had created my dictionary. If I required any additional things, I will keep on adding. Okay. Now, let's create the Python core functions. Now we are going to play with Python first. Okay. Let's create the Python core functions. I will say define. And the first function which I am going to create is I need to pull the data. So I will say fetch region data, because there are regions in the file and I want to pull the data based on the regions. I will create this Python core function which is fetch region data. I will also give this heading as Python core function. Okay. Inside this, I will pass the region name because that's what name is saying. And then I will pass the quarks. And you already know what are quarks. If you don't know, I don't know what you are doing, guys. Please watch any tutorial to understand about the quarks. Now, I need to mention TI because that's the default one provided by Airflow. And I will say quarks of TI. Yes. Now, I need to pass the URL from which I need to pull this data. And obviously, this is API data. So I will go back. I will go to XLE and this URL I will copy. I will paste it here because this is the URL from where we will be pulling the data. Now, this is my JSON. This means I need to import JSON library as well. So I will say import JSON. Very good. This is done. What else? What else? Yeah, as of now, this much. Yeah, perfect. Now I need to send the request to this URL, right? So let's create a variable. Let's say response. And I will say requests dot get this URL, and the timeout is, let's say, 15 seconds. Okay. Now this is the error. Why? Because I need to import the library. So what library? I need to import requests. I will say import requests. That's it. Done. Very good. Now response is also done. Now I will say if my response status code is not equal to 200, this means API thrown some error. So I will raise a exception and I will say f string of failed to fetch live data from this dummy URL Jaswinder. Okay, perfect. Now I will also print the status code. That's why I had mentioned f string. So I will just add dot, I will do space and I will say status. Please give me status. It will be helpful when I am doing the tracking. If anything fails, I will say response dot status code. Perfect. This is also done. But if my response dot status code is 200, this means I am able to successfully ping the URL. Okay, in this case, what we need to do, I just need to store this. So I will create a variable, let's say all countries, COUNTRIES, all countries, and I will store this response. I will say response.json. Okay, now I had stored this. Now I will create a list because I will be using this list as reference. Okay, so I will say parsed data is equal to list. Perfect. List is also done. Now I need to iterate on this JSON. So I will say for country in all countries. This is how we work with loops, right? Now, if I check if not instance, this means if the country variable is not a dictionary, skip the rest of this loop iteration. Okay, so this is what it means by if is instance, then I will pass country and the dictionary. Okay, so this will indicate the same. I will say continue. I will not skip. I will say continue. Perfect. But if it is dictionary, very good. Now I will say I will create another variable which is current region, which will be used to get the region. And if the region is not there in my dictionary, I will name this as unknown. So it's like just adding something extra. I will say current region, and I will say country dot get the region from this dictionary. And if the region is not present, no problem. Say unknown. Perfect. Now I go to the region. Now I will say if my current region dot lower is equal to my region dot lower. This means my region is not unknown. Then only I will move further. Okay. If my region is unknown, I will do something else, which I will show you. So if my region is known, this means my current region matches my region name, which is obviously coming from here. If this is matching, then I will first get the name. I will say name object, and I will say country dot get. What to get? Get this name. Okay, perfect. And I also want to get the country name. So I will say country name. I will create a variable country name. I will say name object. Please get me either common, let's say, or unknown, whatever is there, because I have seen some is common. Unknown, if there is something like that, please get it. And if this is instance, if is instance, and the name object is the dictionary, this is true, then only get this. Okay, then only get this. But if this is not a dictionary, then I will convert this into a string. I will say str of name object, comma, name object or unknown. You can also write these kind of codes. Just do some lead code questions. Whenever you are implementing something in your projects, first try to write code with pen and paper. Just don't go and use GPTs and all those things, because eventually you are not using your brain. And again, you should do this only when your project have a relaxed time. It's not that your project is having a tight deadline and you are just writing code with pen and paper. No. Okay. So maybe in your weekends you can try this, because this is how I learned. I used to write the code on paper back in 2021, that how we can fetch the data from S3. Then I used to go to Stack Overflow and multiple websites. I used to remember the code. I used to remember the libraries. Then I used to again write it. And then finally, once I was satisfied, then I used to write the actual codes using my personal resources. And this is how I learned. And it's not something which I learned in a day. It's a journey which we have to live. Okay. Anyway, coming back to the topic, country name is done. Let's also pull the capital of the country. I will say capital object, and I will get the capital. I will say country dot get. What we need to get? We need to get the capital. These are all the columns present in the JSON. Okay. I had seen the JSON, so that's why I am remembering these things. Okay. Even though I can show you, I guess. The whole intent for this tutorial is to get to help you understand how you can use Airflow effectively. Okay. Now we had get the capital, but if the capital is not present, then I will print none. Okay. Very good. Now I will again create a capital variable, because this is the capital object. It is having everything. Now I'm creating a capital variable. So I will say capital of object, and I will get the first thing. And then I will say if is instance again. If this is instance, every time I am checking if my instance is exactly which I am expecting or not. In this case, if my instance is list and my length, let's say, length of my capital object is greater than 0, this means it is not empty. Then only fetch the capital object 0. But if it is not true, I will say else, please convert this into string or none. Very good. Now I will use exception handling, because I am going to convert these columns into other data types. There is a possibility that data might be corrupt in the population. I might be seeing string. So I need to handle that, these exceptions as well, right? So I will say try, and there I will create a new variable which is population, and I will say equal to integer. Convert my country dot get the value of population. And if it is not present, if you are not able to convert my population column into integer. And if you are not able to do that, just make that default as 0. Okay. Now I will also say except, because we need to handle exceptions. So except will be, if this is failing, no problem, I will say value error, and I will also say type error, and I will say population is equal to 0. Yeah, I had defined it. That's it. Done. Now I need to store these information of capital, country, region, and population, whichever we had created, into the list which I had created in the line number 27. Right? So now I will say, in order to store the things in list, you know how to do that. All you need to do is you just need to say list dot append, right? So here also I will say the same thing. I will say parse data dot append, and here I will pass this as a dictionary. First column is country name, country name, right? Yes, country name, and the country name should be equal to this country name. Second column is my capital, copy paste, control C, and I will say capital, and here also in front of capital it's capital. Then my region, and my region is this one, current region, right? So I will copy here and I will name this as region, and I will paste here my current region. Fourth thing is population, and population is population. You had seen this. So I will again say population, and population value should be population. That's it. This is how I had stored all the inputs inside my list. If I re-explain you the code, first thing, I had created a core function which is taking the region name, and then I had passed my URL, and I had requested to get the information from this URL within 15 seconds. And if the status is 200, I am okay to store this JSON into my variable. But if this is not 200, then I am immediately throwing the error. Now, if it has stored everything into this all countries, I need to retrieve this information from the all countries. For that, I had used this for loop so that I can keep on iterating one by one. Okay. Also, I had created a list which is empty, where I will be storing the final output for this for loop. Okay. First thing, I had checked that if my country is dictionary or not. Yeah, and if this is a dictionary, then I am proceeding and storing this value inside the country region for the region. Okay, I'm saying country dot get only the column region. And once the region I got, I am actually mapping the region with my region name. Why I am doing this? Because if the if the current region is unknown, what I will do with that column? It is not beneficial for reporting, right? If the current region is unknown, what they will do with the unknown? Anyway, then I am creating a name object which is storing the country dot get name. Similarly, I am storing the country name which is getting the country name. Then I am storing capital which is getting the capital. Then I am doing the data type conversions for the population. And I know that whenever you are doing for conversions, there is a possibility of getting error due to corrupted data. And that's where I had done the exception handling, applying the try and except. And at last, once everything is done, once all the four columns are generated one by one, iteration by iteration, it will keep on storing inside this parsed data list. Now, I guess it's the time I should go outside of this for loop, and I will do one more backspace, and I am on the same line as the for loop. Indentation is very important in Python. Now I will print. I will say live data success. Anything you can say. And then I will say extracted. I will also print this parsed data. So I will say extracted this parsed data. I will say length of parsed data and how many rows are expected for which region. I will mention that for region, which region, region name, which I am passing as a value. Very good. Now I need to push this somewhere, which I will do after, because this is my Python core function. I had stored everything inside my parse data. I also need to return this or push this. Okay, no problem. We will do that. I will just give this a comment that do pass parsed data somewhere. Okay. Now, now we have our parsed data. Okay. This means we had successfully implemented the first part where we are fetching the data from API using Airflow. Let me go back and I will go to this Airflow. And here we had done this part and this part as well, right? Partially, not fully. So I will say partially here. So we had done till this point. Okay. Now we need to do this part. This part is getting the data and loading it back into my Snowflake. So this is done. This half is done. Now let's do other half as well. Okay. So I will go back to my Python and here I will create the another function. I will say define. Now I will say combine my data. I will say combine and load to Snowflake. This is what we need to do, right? Combine and load to Snowflake. Perfect. Yes. And here I need to pass the quarks. Obviously, you know why. So I had passed the quarks and now I need to pull the parallel results. That's why we are passing quarks, right? So I will again say Ti is equal to quarks of Ti. That's it. Ti is equal to quarks of Ti. So in this way, I will be pulling the parallel results from the XCOM keys, which obviously we will be passing. Now, Jaswinder, now we need this data. Then only you can create this combine and load to Snowflake function. Yes, guys, this is the time where we should do something about parse data. Let me do it. It's simple. I will say ti dot and I will say xcom underscore push and yeah, then I will pass the key. That's it. I will say key is equal to f string of region underscore name and I will also say underscore data underscore key. Anything. I'm just naming it. Okay. And what is the value? This is my key and value is my parsed data because this is just the name. I am just giving the key name. I can even give the key name as Jaswinder. Okay. So why I had given the region name? Because in my case, I am having two regions, Europe and Asia. So that's why it's best that it should be having a Europe underscore data underscore key for Europe and Asia underscore data underscore key for Asia. So that's why I'm passing this dynamically. But again, I'm leaving to you. You can explore this. Anyway, let's create two variables. First is Europe data, and I will say ti dot xcom pull, right? Because here I had pushed the xcom value in the ti. Now I need to pull this. So I will say ti dot xcom pull, and I will mention the task IDs. I will say task underscore IDs. And what is my task ID? And I will name this task ID as very relevant. And I will say your fetch your data because this will help me in better visualization. And obviously, I need to pass the key, right? And what will key here? Now you know why I had passed this dynamically. Because I am doing the Europe data, the key will be Europe underscore data underscore key. Very good. I will say Europe underscore data underscore key. Done. So if I am pulling this data from XCOM pull, there is a probability that this might be empty as well. Okay. We need to handle the edge cases as well. So I will say if this is empty, then no problem. Just create a Europe data list. Similar, I will do with my Asia data. I will copy this. I will paste it down. And instead of Europe, I will say Asia. And here also, I will say fetch Asia data. And here also, I will say Asia key. Done. That's it. Now we have the data for Asia and Europe. And we have the data in the form of list because this output is the list. So when we pass the variable to the list, it will automatically become a list, right? Now, let me beautify this. Yeah, one more space. Yes. Now I will combine both of the list. Okay. I will say combined underscore list is equal to Europe data plus Asia data. That's it. This is how we can combine the list, right? Very good. Now, I will say if it is not the combined list due to some XYZ reason, there is some error. Okay, no problem. I will raise the error so that I can easily backtrack it. I will say pipeline execution stopped. Just see. Okay, no problem. But if this is a combined list, I need to go to Snowflake and I need to load this list, right? For that, I need to import some library, but I will show you the error first, then I will import the library. No problem at all. So I will create a variable naming as, let's say, Snowflake hook, and I will use Snowflake hook here. So I need to import this, obviously, but let me first show you the error. I will say Snowflake underscore hook, hook. Yes. And now I need to, inside this, I need to pass the Snowflake connection ID. I will say Snowflake underscore con underscore ID, which is my Snowflake underscore con. So which we had created, I will show you again. Go to my Airflow, and then here you can see Snowflake underscore con. So all this is what I am passing here, Snowflake underscore con. That's it. Now I need to resolve this error. It's fine. All I need to do is I just need to import the library. So I will say from airflow dot providers dot snowflake. And you remember we had done the similar thing when we was working with AWS. We had done airflow dot provider dot amazon dot aws dot hooks. Remember? Same thing we will do for Snowflake. We will say airflow dot provider dot snowflake dot hooks dot snowflake. That's it. And this is, you need to remember, obviously this is library. Now I will say import snowflake hook. Similarly, I will copy and I will take the advantage of this time to create the Amazon as well. Instead of Snowflake, I just need to say Amazon, right? That's it. Else I will be coming back and taking your time, which I don't want. So I will say S3 hook. Done. Now we have both of these things. And by the way, after Amazon, it should be also AWS, else it will throw error. Yeah, I guess this is fine. Amazon AWS hooks.s3, yes, and yeah, perfect. This looks good to me. If anything fails, no problem, we will fix this. Now I will come back and I have this Snowflake hook imported. Now I will again create a new list for the inserted queries which I will be returning. So I will say inserted queries. As of now, it is empty, nothing is inserted. So now everything is there in my combined list. Remember? Now I need to iterate on this combined list. I will say for item in combined list. Okay. Now I will create column and I will try to pull the country name and capital, obviously. So I will say clean name, let's say, because this is clean data. I will say clean name and I will say item of country name, because this is what we passed, country name. And if there is any kind of, let's say, garbage values, let's replace them as well. So I will say replace any kind of single quotes or double quotes, just replace this. Okay, so this is some extra step. It's not mandatory. I'm just doing it. Similar way, you need to mention the capital. So I will just copy, paste it below. I will say clean name. Instead of clean name, I will say clean capital. Yes. And here also I need to pass the capital. Done. That's it. Now I need to insert this. So I will say query is equal to f string triple quotes. And here I will say insert into something. Now we will go to Snowflake because I need to create all those things. So in Snowflake, first thing I had created a database. Then I had created a schema. This is how Snowflake works. Then I had created the warehouse. Okay. Then I had created a table. Once the table was created, I had created a role and then I had assigned some privileges to the role, let's say. Okay. And once the privileges I had assigned, I had created a user which will be seeing all of these things. And once the user is created, Then I had again assigned the roles, and I had just done the select star. Okay. I know my table name. I know my schema name. I know my database name. This is my table name, schema name, and database name, right? I will literally copy this. I will paste it here, insert into this, and I need to mention the column names, which is my country name column. I will say country underscore name. Then I will mention the capital column. Then I will mention the region column. And at last, I will mention the population column. Yes. Now I will pass the values. And for country name, it is my clean name, right? I should be giving this country name only, but yeah, it's fine. Clean name. And for next one, it's clean capital. And then it should be region. So how we can pull the region? We need to pull the region from the items, right? See here, I am not doing anything for region here. So this means I need to pull the region on the fly. And why I had done these two things is because in country name or capital, there is a possibility that you can get a single quote or double quote, or there is not possibility. This basically I don't thought anything. I just did it. Okay, to be very honest. But yeah, you can do that for region as well. You can do that for population. It's just a cleaning of data. It's nothing mandatory step. Anyway, coming back to the topic, I will pull it this from the item. So you know how to pull. All I need to do is I just need to say item, and then I need to mention the column, which is region. Yes, this is also done. Now I need to pull another, which is population. Simple. So I will say item, and here inside this, I will say population. Done. That's it. Now I will close this because in SQL we do semicolon. Very good. Now I will append this query because this query will not run here. This query will run when I pass this query in the Snowflake underscore hook, right? So I need to store all the inserts somewhere, and that's where I had created this list of insert queries. Now I will store this. I will say insert queries dot append. That's it. And I will store this query. Done. Now I will come out of the for loop and I will check if my insert query is having data. I will say if insert queries, this means if this is having data, then I will call the snowflake underscore hook and I will say, please run this. Please run all of my insert queries and print something as well. Let's say Jaswinder, database, transaction, committed. Okay. Then let's print the length of queries as well. For that, I need to import f string, and then I will say length of insert underscore queries. Done. That's it. Very good. Yes. Now I had inserted my data inside my Snowflake as well. Now I will go to my XLE draw and I will again tick something. This is also done. Tick. This is also done. Tick. Now it's the time to use Airflow to load the data from Snowflake into my S3. Now let's create that function as well. I will come down here and I will say define another function which is extract this data, extract high population data to S3. Again, here I need to pass the quarks. So I had passed my quarks. Yes. Now, here also I will start writing the function. First thing, I need to maintain the connection with Snowflake because now I need to pull the data from Snowflake, right? So I will say Snowflake underscore hook, and I will say Snowflake hook, and I will say Snowflake con ID, and I will pass this ID, which is my obviously Snowflake con. Done. Now I need to mention the SQL query. Why I am mentioning this SQL query? Because I need to store the result inside this SQL query variable. Okay. So my SQL query should be select country name, capital, region, population from my table. What's my table name? Demo DB public country data. Control C and Control V. Done. This is also done. Semicolon and yeah, done. Now I need to establish the connection. So I will create a variable which is connection, which will be pulling the connection, and I will say connection is equal to snowflake underscore hook. dot get the connection, because I had already passed all the variables inside my .env file, so I don't need to bother much. Now I will say cursor. Cursor will try to retrieve all the information. So I will say cursor is equal to connection dot cursor. That's it. Now my connection should be established. Now my cursor should be having all the required connection details. So all I do is I will say cursor dot execute, because I need this select query result. I will say cursor, please execute my SQL query, and whatever you are executing, please store this inside a function called rows. I will say cursor, please fetch all the things, fetch all, and store this inside my rows. Yes. Now I need to convert this into a data frame, because then only I can convert the data frame into CSV file, right? I cannot directly convert this variable into data frame, right? So let's do that. In order to convert the data frame, I need to use pandas library. So I will say df is equal to pd dot data frame, and obviously I need to import the pandas library, else I will be getting the error. But first let me write the script. I need to convert the data frame from this rows variable and convert this into 4 columns. I will mention the columns, which are my country underscore name, capital, region, and final column is population. Done. That's it. I will close. Okay. Now let's import the pandas, guys, because else it will fail and it will again consume more time. So I will say import pandas as PD. Done. That's it. Yes. Now my data frame errors are gone, which is very good. It's the time that I should start converting this data frame into CSV, because now I am not having a row variable. I am having a full-fledged data frame with me, right? So first thing, I will print something so that I can see this in logs. So I will say app string exporting all the columns. For that I will say length of data frame, and I will say exporting all this number of rows from Snowflake to S to Jaswinder's S3. Done. Dot. Yes. So I will be having all the rows here stored. Now I will create a path for the CSV, and then I will convert this into CSV. So I will say local CSV, let's say local CSV path. The path should be, and obviously by local, it is not mean local, it means obviously in S3. So I will say high population countries dot CSV, and this is my path. Now I need to convert this data frame into CSV. For that, I have a function called to underscore CSV, right? That's it. So I will mention my local CSV path, copy, paste it here, and then I will say index is equal to false. Okay, perfect. Now I will create the S3 hook, because now I had converted my data frame into CSV file and it is ready to be loaded into the S3. For that, we had already imported the S3 libraries. All I need to do is now directly call the S3 hooks. And you already know, we had seen that how we can use S3 hook. So for that, I will say, I will create a variable S3 hook, and I will say S3 hook, and it will ask for AWS con ID. My AWS con ID is equal to AWS con ID, because this is how I had defined in my env file, which I cannot show you. I guess it's AWS S3 con. If this fails, no problem. I will again change this to AWS con ID, because either I had mentioned AWS S3 con or I had mentioned AWS con ID. Anyway, now after S3 hook, I need to say S3 underscore hook dot load this file, guys. Please load this file for me. It will ask me what is the file name, and I will say my file name is my local CSV path. And then I need to mention the key. And this key will be the location inside my bucket. And if I'm not having any location, it will create the location. Okay. If let's say I am naming this as exports, and then I am mentioning high underscore population underscore countries dot CSV. Now I will go to my S3. If you see my S3, inside my bucket, I'm not having an export folder. So now this is not my headache. This is the headache of my Airflow to create this folder. But if I don't pass this, it will simply load the file inside my main bucket. Okay. So I am taking the next step to create the folder as well, or directory, you can say anything. Now key is done. Now I need to mention the bucket name, because in my S3 I might be having hundreds of buckets, right? So I need to copy paste my bucket name. I will go here, I will copy this bucket name, because this is the only bucket where I want this to be stored, else it will fail. Now I will say replace is equal to true. This means if already file is present inside my bucket, replace this. It is not a good practice. You can have replace is equal to false, but let's do that replace is equal to true, because we might need to run this multiple times, because I'm literally writing it right now, right? Anyway, this is done. I guess till this S3 will be able to load everything in the bucket. Now let's print the statement saying that file is loaded. Jaswinder dot dot dot. You're done. Yes, I guess this should work. Now I had created everything as a Python core functions. Jaswinder, you had not created any DAG and you hadn't created any tasks. How you will create this hierarchy now? I know, guys, how. Let me tell you how. Now I will say with DAG. This is the another way to create a DAG. You don't need to always mention at the rate DAG decorator everywhere. That's a good thing. That's not bad thing. And even this is not bad thing. It's your personal choice. Okay. First thing, I will give the DAG name, and DAG name I will give same as my Python code name, which is end-to-end data pipeline. And this is done. And now I will pass the default arguments. And now this is why I had created the default argument, so that I can pass those default arguments here. This is not fully relevant, like owner is Jaswinder, but you will see what I mean. Okay, just bear with me. Okay, now default argument is there. Let's add some description as well, because it's flexible. Description or comment, whatever. So I will say description is end to end pipeline for data to dollars. Perfect. Now I will also mention the schedule, and I will say schedule is nothing, no schedule, because I will run manually. And you can also mention catch up if you want. No, I don't want any catch up. So catch up is equal to false. This will be represented as tag. Now this became my decorator. Oh, yeah. Now I will define the tag workflow structure. So first, I will name the Europe pipeline as well as my Asia pipeline, and these two pipelines will come in parallel, because these two are APIs. So I will name this as fetch Europe data, and here I need to use the Python operator, because we had written everything in the core Python, and you already know the types of operator. We have Python operator, bash operator, then we have email operator, and couple of more operators, right? So I will use the Python operator here. I will say Python operator. Now I am seeing this error. Why? Because I had not imported this Python operator as well. Let's import this as well. I will go up, and here I will say from airflow dot operators dot python import Python operator. That's it. Done, right? Yes. Now I will go down, and now this error is gone, which is good. Inside the Python operator, I need to pass my task ID. And what should I give the name as task ID? Let's say I will give the same name as this variable. I will say task ID is this one only. And then I will use a function called Python callable. Why I'm using this Python callable function? Because I need to call the complete function. Okay, which function, Jaswinder? Because I am first working with fetching data, so I need to obviously do this one, fetch region data. So that's how we can call within the Python operator using Python callable function. Okay. Now, is there any parameters which we need to pass? Because Jaswinder, you mentioned here that you need to pass region. Yes, guys, we need to pass it, because this is relevant to Europe. I will create one, let's say Quarks, and I will say region name is equal to Europe. Done. That's it. That's all. Similar way, I will create the Asia operator as well. I will copy paste. Instead of Europe, I will say Asia. And here also I will say Asia, because this is just a task ID. Task ID can be anything. Here also it will be Asia. I had successfully created two tasks. Very good. Now these two are parallel tasks. Correct? Now I need to call the third task. And obviously we had not defined any dependency. No problem. We will define the dependency, or let me define it right now. So these two are parallel tasks. So I will just use this variable here, and I will say comma, and you know how to define the parallel task, right? So this is how we define it, right? Let me now do some enters, and let's create the third variable, which is to load into Snowflake. So I will say load to Snowflake, and here also I need to use Python operator, right? So I will say Python operator, and here I just don't need to do much. I just need to define the Python callable and the task ID. I will say task ID is equal to same thing which I had defined the name, pass it here, and then I will say Python callable, Python underscore callable. It should be the name of my function. What is my function name? Exactly, I will copy and I will paste it here. Done. Second one is also done. Double arrow, and then I need to define this one as well. Now the final one, and you know the final one is for exporting to S3. So I will say export to S3. Again, I will say Python operator, and then I will mention the task ID is equal to same thing, export to S3, and then I will mention the Python callable. Python underscore callable is equal to the function name. Let me copy paste the function name. It is extract high population to S3. And yeah, that's it. Now I will save this code, and I will refresh this, and I will go to my Airflow. And now if I go to DAGs, I should be able to see DAG or error. And in this case, I am seeing error. That's a good thing. That's how we work. So it is saying TIIME. Jaswinder, it's time. You are mentioning TII. No problem. Let me fix this. I know it's first thing. So I will just remove I, and I will just save this again. I will go back and I will remove this and I will refresh it. That's it, right? Again, one error. What is the error? It is saying with DAG. DAG is not defined, Jaswinder. Do you mean DAG? No, no, no. I mean DAG only. So this means I need to import that as well. No problem. I had imported DAG and task, but I had imported from airflow.sdk, which is journal DAGs and task, which is not relevant here. But anyway, I will import here. I will say from Airflow, import DAG. Done, sir, done. Let me go back and let's see what error now I get. Hopefully, no more errors. Yes. Now I am not able to see any error. Let me open this pipeline and see, guys, it had messed up. It had messed up with the export. Why? Because I had not defined dependencies, it seems. Yeah, see, guys. Silly mistake. No problem. I will define the dependency as well. Control S, go back, refresh, and done. See, guys, this is how we had created the DAG. I don't know it will work, it might not work. But the first thing is that we had successfully created our DAG as per the requirement. We were pulling the data from API using Airflow, then loading into Snowflake, then loading into S3 as the CSV file. And same we have the DAG. API, fetch Europe data, fetch Asia data. Then we have load to Snowflake. Then after data is loaded into Snowflake, then we are exporting to S3 as a CSV. Wow. Now let's try to trigger this. It might fail, it might not fail. I'm not sure. Let's see. Okay. First is pass. This means it has successfully fetched the data. Second is failed. Load to Snowflake is failed. Why this is failed? Let's see that. Snowflake hook is not defined. Okay. No problem. I will go back to my code. I will go to my Snowflake code. This is my Snowflake code. And I guess this is the error, line number 74. So yeah, because I had mentioned underscore and there should not be underscore. Yes, now it should work. No problem. Let me refresh this. and let me re-trigger this. Oh, before re-triggering, I need to stop this, and I will just say failed because it is failed, and I will also make this as failed. Perfect. Now, let me rerun this, trigger it again. Yes, trigger. Okay, these two pass, and hopefully this should also get passed. Let's wait for a while. Because it is loading data to Snowflake, it might take a while. That's fine. That's totally fine. Take your time, no problem at all. Let me refresh this. Okay, it's still running. Let me open this. I want to see the logs. Okay, everything is running. Okay, it is fetching the data. Perfect. So this means it is running. I can close this and I can patiently wait here maybe. And yes, it had successfully ran the load to Snowflake as well. Now it will Now it had also ran the export to S3 as well, which is good. This means everything is done. Let me go to Snowflake and check, do the select star, and I can clearly see the data and 103 records inside my Snowflake. So this means till this part, everything worked. Very good. Now I need to check this part, right? Let's go and check that as well. So Snowflake is working. Now I will go to my S3. I will refresh here, and here I should be able to see export folder. Let's wait, it's loading. Okay, I can see export folder because I had mentioned the exports. Inside this, I should be able to see CSV file, and I am able to see the CSV file. Let me download this file, and let's see if the count is matching, because in my Snowflake, I can see 103 count. Here also, I should be able to see 103 count, right? Let me see that. It's downloaded, and I will click here, and here I can see the data is populated, which is good. The count should be 104. Yes, everything is matching. With this thing, we had literally implemented the end-to-end project as well. This is all about Airflow, guys. Okay. And there is a very big room to understand more about Airflow, and it will keep on evolving as all the technologies are keep on evolving. So I recommend you to go through all the topics and try couple of more things on your own so that you get a very good grasp on the Airflow. Okay. Let's now cover the last topic for this complete tutorial, which is orchestrating the multiple DAGs as the parent DAG, which is also known as inherited DAG. So as you know, normally we had scheduled a lot of DAGs, and we had scheduled one DAG with multiple tasks, right? This is what we had done till now, right? But there is also a scenario where we need to schedule DAGs as well as the dependency, right? Because that is also the regular thing where we need to orchestrate multiple DAGs, right? How we can do that? Just before directly jumping into creating the parent DAG, this is somewhat how we will be scheduling the multiple DAGs. So we will be defining the dependency inside a parent DAG Python file. Okay. Now let's go to our VS Code, and now I will create three files. First file I will create is child DAG heavy. Anything, it's just the name. Second file I will be creating is child DAG light. Okay, no problem. Yeah. So two files are created, and the final DAG, which will be scheduling both of the DAGs, I will be naming that as parent master DAG. Okay. Now, first thing I will create the code for child DAG heavy, and you already know how to create the code. For that, I just need to say from Airflow import DAG. And then if it is required, I will just import it from datetime, import datetime. As you just came to know the second way to define the DAG using the with command, I will be using that way here as well. So I will say DAG, and here inside this, I will pass the DAG ID. And let's say the DAG ID is child DAG heavy. Okay. Now I will say comma. I will mention the start date, which is my date time of 2026 1 comma 1, and then I will mention my schedule. And obviously I won't schedule this because I am going to schedule this with the parent DAG. I will say schedule is equal to none, and if optional catch up, obviously I will just say false. I don't need to do catch up. And then I will say take consider this as a tag. Now I will create a task. But before I create the task, I want you to take back to my Excel draw. And here I want to tell you something which might be you are already aware, but still I will tell you that in order to work with the multiple tag scheduling, we need to use a special Python operator which is known as trigger tag run operator. Okay, and this operator allows a parent DAG to trigger all the independent downstream child DAGs. It even passes the parameters for them, and optionally it will even wait for them to finish. We will do all these things, but let me first write the operator name, which is trigger DAG run operator. Okay, I will make this bigger. Yes. So this is the operator which we will be, yes. So this is the operator which we will be using to schedule the multiple tags inside my parent tag. Okay. Let me write the definition of that as well. So I had written the definition as well, that trigger tag run operator allows a parent DAG to trigger the independent downstream child DAGs, and it will pass all the parameters to them, and optionally it will wait for them for the completion if we pass wait for completion is equal to true. Okay, and now I will go back to my child DAG and I will keep on doing what I was doing. So first thing I will say task underscore one, and let's define the first task. And obviously here I need to use operator, either bash or Python. Let's go with the bash operator because I will be very quick with this demo. I will say bash operator, and I am seeing the error. Why? You already know, because I had not imported the bash operator. So I will say from Airflow dot operators dot bash import bash operator. Done. That's it. Nothing rocket science here, right? Error is gone now. So inside the bash operator, I first need to define my task ID. So I will say task ID is equal to, let's say, heavy ETL part 1. Okay. And the second thing I need to define is my bash command, which I need to run. I will say bash command is equal to echo running heavy processing step 1 for Jaswinder, and I will just copy and paste it below, and I will create task, and I will say running file processor step 2, and here I will say part 2 and step 2, and I will create one more. Let's say this is my task 3, and here also I will say it's 3, and here also it is 3. Very good. Now I will define the dependency. That's it, right? So I will say run task 1 first. I will say task underscore 1. You run first. Then I will run both of the task in parallel. I will say task underscore 2 and task underscore 3. Very good. I had successfully defined my child tag. I will save this and I will copy paste this same in my child tag light. And here I will just change the names. Instead of heavy, I will say light. Okay. And yeah, here I will just say, let's say, define one task only. I will remove other task, and I will say instead of task 1, let's say light task. Okay, light task. And yeah, I will say heavy light. I will say instead of heavy, I will say light task. Then running light for Jaswinder. That's fine. And I will save this as well. Done. So I had successfully created both of the child DAGs, right? Inside my first DAG, I am having 3 tasks. Inside my second DAG, I am having a single task. Now it's the time that I go to my parent operator, and as we had discussed, it's also the time to define and use the trigger tag run operator. Okay. Now I will go back. I will copy paste the same code, and here inside the tag, I will say parent master tag YouTube. Okay. And inside the schedule, let's say I will just say @daily. I will just set the preset. Yes, that is also done. And I need to put this in single quotes. Yes. Catch up is false. That's fine. Tag good. Now I define the parent task. Plus, inside the parent task, I will schedule this tag. That will be much good use case, right? Let me go to Draw and let me change this little bit. Okay, let's make this one more step ahead. So what first I will do here, let's say this is my parent tag task one. So I will first not run the tag one. First, I will run the task of the parent. There is a possibility, right? Parent can also have tasks, right? It is not the case that in parent we will be only running the tag. So that's why I am rectifying my diagram and I am going one more step further. Okay. So first I will run this task one. Then I will run these tag one and tag two in parallel. Okay. Let's complicate this. No problem. This is how we learn, right? Yes. So now this is my new diagram. And let's also define one more task for my parent. So here I will just say final task for parent. Yeah, this looks more real world instead of just scheduling the tag, because obviously we had done the project also, so it is no sense that I will be just simply scheduling the tags. Okay, so that's why I'm taking the next step for you guys. Perfect. Now we are going to build this one now. Very good, Jaswinder. Let's go back and let's implement this. So first thing, I will create a task only. I will say start pipeline, and I will use the bash operator only. And here also in the task ID, I will pass the start pipeline. And then in the bash, I will say initializing our tag. Don't mind my spelling if it is wrong. I am going very fast. Same thing, I will remove this first. Same thing I will create as a end, because at last also I need to create the end tag. So let's say this is my end pipeline, and here I will say instead of start I will say end, and I will say echo well done. We had completed the Airflow 3.0 tutorial. Perfect. This is also done. Now let's schedule the child DAGs inside this. And you know how we can do that? We can do that using trigger DAG run operator, right? Let's do that. So I will just first define a variable. I will say trigger heavy DAG. Okay. And now I will use that variable. What is a variable? Variable is trigger DAG run operator. That's it, right? This is the variable. Now I am getting the error, and you know why I am getting this error. Simple, I will fix this, right? No problem. So I will say from airflow dot operators dot trigger diagram, trigger underscore diagram, I guess. And yeah, then I will say import trigger tag run operator. That's it. Done. Now I will come back to my discussion. And now this error is also gone. This means there was underscore. Perfect. Perfect. Yeah, sometimes, we forget things. So that's fine. No problem. That's human nature. Then I will define the task ID for this tag. Okay. And don't worry, this is not the task. We know that. It's just the name of the tag. Okay. So I will say trigger heavy DAG. Okay. Now it will make sense to you because I had mentioned DAG name. Okay. Now I will mention the trigger DAG ID. Trigger DAG ID. And now you are sure that I am going to schedule my DAG because I am mentioning the DAG ID. What is my DAG ID? Let me go and let me grasp it. DAG ID is child DAG heavy. I will come here. I will paste it here. Then I need to mention the wait for completion, because I don't want that if my tag 1 runs successfully, it will immediately trigger my final task. I want both tag 1 and tag 2 should run in parallelly and should be completed. Then only I want to trigger the final task. Okay. That's why I am mentioning this one, which is wait for completion. Okay. And obviously it is true. And now I will mention the poke interval. What is poke interval, Jaswinder? It just the check the status of your child task. If all the child task ran successfully, then only it will give the green flag for the entire tag. Okay, so this is the poke interval. Let me add the comment. I will say checks child status every 10 seconds, because I had mentioned 10, so it will check after every 10 seconds. So that's it. I had literally defined my first DAG. Now I will just copy, paste it below and define the second DAG, which I will name that as trigger light DAG. And here also, instead of heavy, I will say light DAG. And then I need to mention my child DAG name, which is child DAG light. I will copy and I will paste it here. And yeah, everything else looks good to me. This means everything is done. Let me beautify this. And yes, now it's the time that I define the dependencies, right? Because we always do the same thing. We need to define the dependency. And first, I want to run this start pipeline. And then I want both of my DAGs to run in parallel, right? So I will copy paste. That's it. I will say run this DAG and please also run this DAG in parallel. Airflow, please. Then I will mention my end pipeline. And yeah, done. That's all we need to do. Now I am on my Airflow and I can see the child DAG heavy as well as the child DAG light. Let me open the child DAG heavy. I can see part 1, part 2 and part 3, which is good. Now I will just enable this because without enabling it won't work. Second, I will check my child DAG light. It should be having a single task, light queued part 1, which is really good. Now I need to see if it had passed my final parent tag, and I can see that as well, parent master tag YouTube, and it is having all the four things: start pipeline, trigger light tag, trigger heavy tag, and end pipeline. And this is exactly which we was discussing: start, tag 1, tag 2, and end task, right? So in this case we are having two tasks and two tags, and you can see here in the task it is mentioned the bash operator, but in my DAGs it is mentioned trigger DAG run operator. That's the difference when we are scheduling the DAGs and task all together within a single DAG. Now I guess I had enabled both of them, but let me recheck and I will check here. Child DAG heavy is enabled, which is good, and child DAG light is disabled. Let's enable this, and now I will go back to my YouTube DAG. I will enable this and I will go inside, and now I will trigger this. And let's see how it ran successfully. Good. Let's wait for light and heavy DAGs. When both of them will be success, then only it will trigger the end. And see, both of them are success. And now trigger will be running. And yes, everything is done and dusted now. With that said, we had completed the entire Apache Airflow 3.3, and there is no other concept left as per my knowledge. And I really wish that you had enjoyed this video. If you really had enjoyed the video, please do consider subscribing. Please do like my video and I will really appreciate you guys. See you in the next one. Thank you so much for watching this one. Bye bye.